So what we're going to talk about first, well, all day today we're going to talk about spatial pooling. And in particular, we're going to talk about what we've been calling K-winners activation recently, which is the Minicolumn competition. And I'll actually show you first, in case you guys anyone has followed along with any of this stuff on HTM School. I'm going to show you.
This is the most amazing thing.
That, of course, bugs me every time. I'm going to show you. Let's see here. Here's the link to HTM School. I'm going to show you the exact video and the exact part of the video, right, that I'm going to be talking about. Let me just get this. I still don't quite have things arranged where I want them. There we go. Yeah, I'm happy to lower the music volume. Thanks for letting me know. It's a little loud for me too. Okay, so spatial pooling starts here all the way down in 7. Okay, so I'm gonna mute this, and we're gonna find. Do we talk about the competition in this one? I think we don't. Do we? Not quite. I thought maybe I don't even talk about the competition until the next one. So this is all about the input, excuse me, the initial permanences. I didn't talk much about the initial permanences, but I did show how things were connected. The part, episode 8 is about learning, and I think that's where we talk about the competition. So this bit over here, with the stack on the right, and I think eventually I talk about this, we're deciding for each input step which mini columns are going to be active, and that's what this stack on the right is, and it's over there with the green, and then we draw a line like right down the side of it, right in the middle of it. That's the K. That's K. How far down we put that is K. And the top are the winners. So this is K winners. If we're talking about how we talk about this as a machine learning activation function, it does introduce what you'd say a non-linearity into like a machine learning type of system. So we're going to code this K winners thing today, and we're going to do it in visuals or in simple. First of all, we have to go do it in simple HTM. Now, eventually we're going to end up in building HTM systems, but the spatial pooler is in building HTM or is in simple HTM. Let me just get everything from upstream. I think, am I up to date? Get pull origin, or get fetch origin. There we go. So I have a couple of branches here. I'm gonna go to this. I think the git checkout live stream. Great. Code dot. Let me make sure I'm in the right place. So what I should have here is I kind of did a little bit of prep work, and I created a bunch of tests. Let me make sure I have the tests. So maybe I don't. That's weird. They're not there. I had them, I swear. Oh, there they are. Okay. So we were working on these last time, and so let me sort of try and pick up where we left off. In a way, I got it. So the last function that we were working on was testing something. Was testing the permanences, the initial distribution of permanences. And what I was trying to do that I was getting so frustrated with was I was basically trying to test the random Bates distribution function I was calling D3 for. What I should do is trust that function works. And if I'm using D3 as a library, I should have enough trust in it to trust that it's doing what it's doing. So I shouldn't be trying to test that distribution, right? So I'm not going to do that. So I sort of stopped there. All I did test was that the permanences are averaged across the whole thing. They are centered where they should be. So how we create this spatial pooler is we're going to give it how connected it's going to be, and a distribution center, and that's somewhere between 0 and 1. And so we're actually doing a for each here, so we're testing 30, 50, and 60, or 0.3, 0.5, and 0.6 different points in that line, where we're going to center the distribution. And again, I really should, we already have a visualization for this. So if we go to build, building HTML systems, it'll take a minute to boot up because it's a on-demand Heroku app. This is where our latest code gets pushed whenever we push to this. So we don't have the spatial pooler running here yet, but that's what we're gonna do today. We're gonna finish out the spatial pooler. We're even gonna add a Minicolumn competition. But this is what I'm talking about. That distribution, that histogram right there. If we average all of the connection permanences across the whole range, it should center right in the middle of that distribution. So that's what we're gonna test. Whether we move it, whoops, that's the wrong one. So if we move it and we make it, you know, point 2, not 2, 0.2, then the average of all of those weights should be 0.2. So we're checking on that. Hey David, welcome. I'm just going over some of the motivation for this. We're going to talk about the Minicolumn competition, but first I did want to show that this was working. So I think I'm in a place right now where this passes, and then we're going to look at additional tests. And we're going to just put in place the Minicolumn competition. So I've written the tests, and we're going to go through and uncomment the tests, and then we'll write the code to make the tests pass. So let me live share this since you're here, David, and you've been joining in. Put this on chat. For anybody out there who doesn't know what we're doing, here's a link. Okay. Hello, welcome. Hyung-song, go. I hope I'm not butchering your name. Okay, so there's no server for this one. This is all we're gonna do is run tests for this. So first things first, I ran into this right away. We need to make sure that the permanences are the same every time we call them. If we haven't computed, if we haven't learned anything, those permanences need to be the same. So that was one of the first things that broke for me. And if you run this, I think I have this set up. I need to, I'd like to run this from VS Code, and I found a great link on doing that. VS Code Mocha test launch. There it is. This was perfect. This was like exactly what I wanted. These two configurations worked perfectly for me to run my tests. So I think I go to add configuration. Yeah, so the configuration I want, this never worked for me. This is what I want. So I think this should work now. So if I'm in spatial pooler test, I should say run current file, debug. There we go. An exception has occurred. What happened?
Happened is the simple past tense of happen. Happen is usually defined as come to pass.
Alexa thought I was asking her what happened means, or what the definition of happen. Oh my gosh.
The verb happen is usually defined as to take place, come to pass, occur.
Stop, don't do that. I'm not talking to you at all. Okay, obviously I screwed something up here, and it's probably just because, first of all, I know I need, for launch all, I need recursive. Timeout, workplace folder, node modules, bin, Mocha. This should work. I wonder if all of them, let's try running all. Not that it should make any difference. What is handle error from binding? Okay, so let's make sure, I already ran this, so this test is gonna fail. So I'm just gonna run from the command line because I'm not gonna debug this right now. This test is gonna fail because permanences should not change between computations. And they do, and it's super easy to fix this. All we have to do is basically do the exact same thing that we did get rid of this stuff. The exact same thing we did for the potential pool source algorithm spatial pooler. Okay, so we are going to create this function. We're going to change this from get permanences. We'll call it create permanences, and then instead of so we'll return them there, and then just like this, we'll say this dot permanences equals this dot create permanences. And we'll add a public function, get permanences, to return it. Okay, so this, at least for now, and this isn't going to, I mean, these will update when we get to learning. We're not to learning yet. But for right now, this should pass the test, I think. Oh, maybe not. What did I do? Oh, Bates function is not a function. Oh, that's interesting. That's not what I expected. What did I, Bates function? It's like what did I mess up here? Preeminences? I've got a typo somewhere. Preeminences, thank you. Permanences. But why, that was weird that it gave me that error. That's a strange error. That was a very strange error. It's still the same thing. Bates FN and spatial pooler is not a function. It certainly should be a function, unless it's not a number. Bates independent variables. I shouldn't have to give it that. Something's wrong here. Hold on. Create permanences. I got that right. Create permanences. This is returning all perms. Get the potential pools. Oh, yeah. So I've already got potential pools to use. But when I'm calling random Bates, I have to do this after creating that. That's all. Okay. So I'll set up the Bates stuff first. So just a silly ordering thing, not a big deal. So hopefully this passes now, and then we're gonna trust the distribution. We're gonna trust the Bates coming from D3 that it does the distribution, and I see it in action. I mean, we see it on the histogram, right? That we see it right there. That's exactly what we want, and this is working too. Like if you increase this, it makes it smaller. You can make it really, really tight, or really wide, really wide. So that's what we want. We want that type of control, and it seems to be working. So I'm gonna trust it, and we're gonna move on to further testing. Okay, so this next test is when calculating overlap. So I'm gonna uncomment this whole thing, and everything's gonna fail, and then we're gonna go sort of step by step. And let's see, let's start with this, and I'm gonna explain what we're doing here. Okay. So let me just run this, and I don't think we're testing anything. It's still just gonna run a setup. I have too many of these cases. I should really. So I think what I'm gonna do, I was thinking about this earlier. There's several places in here where I'm testing a bunch of conditions. What I should always do, I think, is only have 4, like in a lower to the 2 edge cases, the min and the max values that I want to consider, and then at least 2 in between. So I am going to, and really they should always be like going in the same direction, right? Let's do 0.3, 0.6, and then 1.0 for connected, because we fully connected. Yes, 0 connected, it doesn't do anything. So there's no point in making it 0. There's another place that I'm doing this too, and I'm gonna do the same thing. This is for the distribution center, and I really only need to pick 2 for this, I think. Maybe we should do 0, but there might be some strange behavior at the zeros, but I guess that's why you test, right? So let's see if that breaks anything. And this one's important because it gets looped. So for this one, let's do, again, input saturations. 0 should hold, 0.3, 0.6, and 1. Okay, so I want to see this. Does that break anything, I wonder? It did. It's probably at the case, it's at distribution center 0. So it's at that edge case of 0. And it seems to be always distribution center 0. Permanence across this 500, average permanence across 500 permanence should be centered at 0. But it's not. So if I make this, so I wonder if this isn't, like if I make this 0.1, would that fix it? If that would fix it, then it's some type of 0 edge case, most likely. That it does seem to fix it. And it may be that we just limit it to not be 0. Like if I put 0.01, I'm just going to leave it at this. This is what we're going to test it at. Because I don't know why you'd ever put it down that low. So just for the sake of complexity, we'll just leave it at that. Okay, so we're getting to overlaps right now. So let's talk about input saturations. All I'm talking about is we have an input array. What percentage of those are on bits? That's the input saturation. We'll have 0, we'll have 30%, 60%, 100%. The input count, I'm going for 1,000 because with a lot of these tests, we need a larger number because we're doing a bunch of means across it. And to do the assertions, a larger number is better. 500 mini columns, we're gonna say the connection threshold's right in the middle, but the connected percent's 85%, so most of them are going to already be connected. Okay, so here's our SP. And so for each input saturation, we're gonna run this test. And now we create the input. The input's gonna be based on the input saturation. And now this is the test where we actually do the overlap comparison. So let's start with the simplest and then move down. And try and make these pass. Because this is going to fail right away, so I'll run it and we'll watch it fail, but I'll also explain what it's doing. So we're saying we want to test that the overlap is within the acceptable limit. So here's the API that I've defined here. I'm going to call on the SP, calculate overlap. Here's the mini column identifier, the index of the mini column that I want you to calculate the overlap for. And then here's the input. I'm happy to draw this. If anybody wants me to draw it, like raise your hand or let me know somehow, because this is easy to relate to theory with a visual here. If we take one mini column and we calculate what its overlap is to the input, I'm gonna get an array back of indices. And these are gonna be integer indices of the input space. So of those 1,000 bits that we defined here in the input count, it's going to be from 0 to 999 basically, and a bunch of these that represents all of the bits in there, I think. Yes, all the bits in the input space, the indexes of those bits that this current column overlaps. And we're going to say, first of all, we know this cannot be more than the input space. Okay, so that's the first assertion we're going to make. Okay, so watch this fail, obviously, because calculate overlap is not a function. But that's the function we're gonna write. All right, so we'll put it up here. So we know it's gonna be calculate overlap. It's going to take, let's call it MC index for the mini column index and an input. The input is gonna be an array of on or off bits. So for this, first of all, we're going to take advantage of any functions that we already have. So we know we need to essentially do a double loop here. We're going to create an overlap output. It's going to be an array, and that's what we're going to return. I want this, every element in this array's got to have two pieces of information. It's got to have, first of all, the index to the input space, like to identify, link this mini column to an index. So for this index, and then we have to have the integer count of how much the overlap is, right? Or the, wait. Yeah, I think that's right. Because what this is going to be is a count for this one mini column, what's its overlap with this current input. So it's going to be a count, right? Now I'm confused. I've already actually written this, so I should like go reference it real quick and make sure I'm doing the right thing. I hope you guys don't like look down on me for doing that, but I want to make sure I'm doing the right thing. .com, Rhyolite, simple HTML. How many inputs project to this SP entry? Well, that's going to depend on its potential pool. So we have to look at the potential pool and the permanences and do a threshold check. That's the long and short of it. Branch. So here's the one that actually works. Spoilers, you guys. If you, I just want to make sure I'm doing this right. Okay, so I get the pool, I get the perms, and then for each perm I loop, and then for each input I loop. Okay, so that makes sense. So to do this calculation, first of all, we'll get the potential pool, which I can just say is this dot get potential pools, right? And I'm going to specifically get the pool for this one mini column index. Okay, so so now I know that this is how this mini column, these are the potential places that we can connect to, and this pool gives me the indices that of the input. That's what we're going to get from it. And so now we also need to get the perms. So we're going to say get permanences, do the same thing, index it by the mini column. And so now we can go and construct this overlap object. So we'll say for each permanence, and I'm also going to need the permanence index, right? So I'm going to need the perm and the perm index, I believe. So in the end, we're going to basically say overlap.push, and we're going to send it something, and that's going to be basically what we're doing here. Hello, you guys. Raimu? Somebody popped in. We are calculating an overlap score for a mini column in a spatial pooling structure. I'm being rated. Thanks guys for joining in. I appreciate it. This idea, I'm gonna go to the whiteboard since you guys are new. We'll go to the whiteboard. Okay. So we're talking about spatial pooling in a layer of neocortex. So if we have a population of neurons, this is like a three-dimensional structure, okay? You have to imagine like a three-dimensional structure. And in this population of neurons, there's neurons all throughout, thousands and thousands of pyramidal neurons. In some of these layers, they get grouped into these structures called mini columns. And these mini columns enforce a particular, what we call receptive field. So all of this mini columns neurons, there's a bunch of neurons in here. All of these neurons are looking at some input, like some data coming from somewhere, right? And they all get the same window into that data. Like this mini column has a specific window it sees of that data. There's other mini columns, like there's hundreds, perhaps thousands of other mini columns, and they all get other windows into this data. They're seeing like a different picture of the data. The input data is the same. Each one of these thousands of mini columns sort of slices it in a different way. So what I'm doing today is I'm creating the logic to choose the winners because all of these mini columns that exist in here are all competing to represent the input in this space at every time step. So you have to think about the input as constantly moving like this. Okay, so the data that's coming into this space that I'm drawing is constantly changing. It's like as you move your eye across an image, or as you touch something, or just as the world changes in front of you. It's constantly changing and moving. So this is sort of like how your brain, and at least in the neocortex, and this is happening at least everywhere in your neocortex, like in at least one layer of your neocortex all over your brain, this spatial pooling operation, it's trying to normalize this data that's constantly streaming into it by running a competition up here. So only some of these mini columns, and look it up if you're into the neuroscience, look up what a mini column is. Only some of these mini columns are going to activate to represent this input data, and so we have this competition. And what this really is a simulation of neuronal inhibition in the brain, because this competition is enforced by inhibitory neurons that we're not even showing in this structure. But what happens is you have a certain number, which we call K, because we're relating it again to some machine learning concepts. Hey, thank you for the follow. Sorry, that's my brain. Look, that's my brain. Look, it's my brain again. Every time you guys do that, you add to the size of my brain. Thank you. So we're having this competition, and what we call it in machine learning lingo is we would call it a K-winner competition, because only X number of these mini columns are going to win out to actually, I've got more colors. Not that color. Not that color. I want that color's good. Because only some of these, there only a very few of them, in fact about 2% of these mini columns are going to actually activate to represent this input data. And this is happening constantly in your brain. Every new input that your brain gets, it's performing this pooling operation to take the massive amount of sensory input data that you're getting. Thank you again for the follow. The massive amount of sensory input that you're getting, and normalize it so that it can run more computations in this space. Because that's the second part, and I haven't even gotten to this yet. There's another process happening here that we call temporal memory, and this is enabled by what we call active dendrites, or dendritic spikes, or NDMA spikes, active dendrites. There's several terms for it. We've been talking about this at Numenta since 2011, but there's a temporal memory operation that's happening within these mini column structures, simply by them having the ability to create distal dendritic connections between each other. And we're not even going to talk about that today. So that's like way beyond this. Your brain is literally blown. Your mind is blown. That's great. That's what I'm trying to do here. So let me catch up on chat real quick. Yeah, thanks for the mission. We have a forum, you guys. So a couple of links I'll send. This is what I'm working on today. It's called Building HTML Systems. It's all the code's open source. So all the code that you're going to see me work on today, you can actually join in and view too. This is what I've been working on. I'm actually working on calculating this overlap given one mini column and an input activation down here. So many bits down here in this space are activated. I'm going to calculate the overlap. How many of these bits, and this is just an actual integer number, 45? I don't know. There's some number of neurons here or bits here in this receptive field that represents how much or how well it recognizes that input, and this is something that involves the permanences. We talked about that in previous live streams, which brings me to yet another point here. Okay, all of those live streams are archived on YouTube. So you can get to all the previous live streams that I've given on this topic where we talked about all of these initial permanences, how they're established. I think I just did that last week. So now we're moving on and we're doing this mini column competition. So I appreciate you guys joining in. Let's continue working on this. Let's see. You're not making Skynet? No, I'm not planning on it. I am making AGI. Like, we are working towards something that you would probably call AGI. This is not the same thing as deep learning. This goes a step beyond deep learning. Deep learning is by nature restrictive because it's the model of the point neuron that it's using is doesn't allow this temporal memory process to happen. So, okay. Let's move on. The idea is, yeah, totally the idea, and if you, I think maybe you already put this, but yeah, our mission is to understand how intelligence works. It's the chatbot put it up there earlier. We're trying to understand how intelligence works in the brain. That's like our #1 mission. So that's, if we can do that, you know, and and I feel like we're making a lot of progress, like especially with the sensory motor integration. If you want to learn more about that, go to HTM School, because there's a bunch of videos. Oh, I've already put that there, yeah. So I have a whole video series that introduces all of these concepts. Here's the playlist. I'll pop it in, it's already there. So all of this stuff that I'm talking about, spatial pooling, input space, connections, learning, and I'm not gonna do boosting today, but eventually we'll have to do boosting. We'll talk about local inhibition, which is the idea of topology. Oh, God, that's something I do need to talk about, I think now, actually, since we're sort of on the topic. So this idea of the overlap and the mini column competition that we're gonna do here is not exactly the way it's going to work in the brain, because when your brain gets sensory information, it's all topological. When you talk about topological, I mean, like there's relations in space that exist in sensory input, and they're discernible, I mean, and they're important. If you remove topology from data, you essentially create a one-dimensional array, and it's just one point of data that has a bunch of spatial information. As you expand the dimensions of the data, you really need to take advantage of the topology that provides you, right? High dimensional data sort of naturally has this topology. So your brain has evolved to account for that topology. What I'm doing here, what I'm going to show now with the mini column competition, does not include topology yet. It's assuming this data is one-dimensional. But that's okay, because we can add it later. And the idea is that I talked about a mini column competition. When you have this competition, you can have one global competition amongst all of the mini columns in the population of cells you're simulating, or you could have local competitions. And you could say, okay, well, this block of mini columns is going to compete, and this block beside is going to compete, and this block, and this block, and this block, and this block, and this block. That's how you add topology. So this idea that I'm going to go through now of finding all the overlaps, stacking them all up, that I talked about in spatial pooling learning episode 8 over here. That if you want to learn, this is what we're doing today. That mini column competition. Whoops, wrong one. That brings up a good point, because here's the topology bit. And so those of you who, does anyone know how like convolutional neural networks work? Raise your hand or say hi or say something. If you understand convolutional neural networks, you've got a leg up on understanding exactly what I'm talking about here, because they're both inspired by the same neuroscience. They're both inspired, and let me get you exactly what they're inspired by. This Hubel and Wiesel work, this is very old stuff, but, oh man, where'd it go? Columnar, or the function, there it is, the functional architecture of the macaque, monkey, and visual cortex. So this work is really what inspired convolutional neural networks. This is a super interesting paper, worth reading. Old paper, but if you want to understand what the brain's doing, it's definitely worth reading. So topology Norcix 2D, 3D, you can think of it honestly as high dimensional. I think it adjusts to the dimensionality of the data. I'm not certain of that, but it seems like the computation should be able to process any dimensionality of data. The only limit is, processing power and how many resources do you have. Anyway, I'm trying to get to the point where we're talking about. Yeah, okay. So this is sort of the interesting stuff. The lesson that deep learning learned from this neuroscience work is that they should break up the input into spaces and process it in sort of localized regions, because that's what. Sorry, we're having an issue outside. Doesn't look like anything exciting's happening. But they wanted to. What they found in the brain is that there's different. There's topological projections, essentially. So there's localized areas of cells that are going to functionally process different areas of the input. There's a lot of interesting things here. People still don't quite understand a lot of this stuff. But this is what inspired convolutional neural networks, and this is also what inspired, I think, the idea of receptive fields in neuroscience, and that there are localized receptive fields, and these mini columns that I showed in this topology video. See how it's bouncing around here as it goes along? Oh, it's muted. So this is similar to the idea of convolutions in deep learning. It's not the same thing, but they're both inspired by the same biology. So that's an interesting link, I think, to relate HTM to machine learning. Is that this idea of receptive fields and mini columns when you have topology is inspired by the same biology as convolutional neural networks. Thank you, Falco, for linking the paper. Let's get back to what we're doing. Okay, so we talked about. I was about to write this code. I'm honestly a bit lazy because I want to get this in place. This is the code that's going to work. So I'm just going to copy it into place. What we're doing here is I have a test. And so I'm doing this in a very test developed way, a TDD way. I'm writing the tests and then I'm putting the code in. And so I'm going through different input saturations of the input space, different percentages. And for each one, I'm testing that certain things are true. So I want to make sure when the input's very sparse, this is true. When it's dense, it's true. Hello, Ascendental. Hello, everybody. Thanks for joining. I know we've got a lot of viewers right now. I'm open for questions, by the way, if anybody does want to ask questions. But I am going to continue driving towards creating this spatial polar mini column competition. So right now, I want to test that when I call calculate overlap, I'm gonna loop through all of these mini column indices that I drew here. So essentially, I'm linking through every single one of these mini columns in my structure. And for each one of these, which is indexed by MC index, I'm going to calculate the overlap. So I'm giving it the input, I'm giving it this input, and the on bits here, I'm giving it to each one of these ones, and I'm going to calculate this overlap based on its potential pool and its permanences. Does that make sense? So once I get the overlap indices, because what this should return me is for that one mini column, here's the actual indices. What I was doing earlier, I was a little thinking backwards. It's going to give me the indices of the input space that this mini column currently overlaps. Now, there's certain things we want to check. First of all, for each, none of these indices should be out of the range of the input. So the first check is we're going to make sure that these are all at most the size of the input, or the count of the input minus 1, which is the right index. So let's make sure that. Hey, thank you for the follow, Steven. I appreciate it. That didn't actually even work. Unexpected token. I think I screwed something up in my copy paste here. Yeah. I just forgot to. Okay. So I'm hoping this will pass this test, and then we can just uncomment the remaining tests and see how they go. So we're going to test that it's not out of range either above or below. None of these indices should be out of range of the input space. The next test is going to be that they're all unique. So there should be no duplicate indices in here. So I'm going to shove them all into a set and just assert that the sizes are the same. Okay, so we already have a problem because I didn't name my variables the right thing. I called this Minicolumn index here and something else. So let's run this test again. Steven says, awesome, I'm a newbie to Twitch, but not HTM. Yeah, I am a real AI evangelist. Thank you for recognizing. I hate the term evangelist, but I can't think of a better name for it. All right, so let's verify this test worked. So we're going across all the connectivities, all the distribution centers, saying contains permanences are normally distributed. That's not even the test that I'm writing. What's the test I'm writing? Here it is. When calculating overlap, with 0% saturation, overlap is within acceptable limits. So it's within acceptable limits in all of these cases. We can certainly make this fail if we want just by adding a -1 here. I assume this is going to fail. I always like to watch tests fail because it's rewarding when you make them pass again. So this should fail if I put a -1 there. So one of these tests that I wrote and that runs through, yeah, so it failed. Good. So there's a failure if I do something stupid. Okay, so that was that. So we're testing that the overlaps are all within a proper range and they're not unique, or that they are unique, excuse me. And so now this next bit is a little bit more complicated. So we're calling the overlap like the length of the indices. So this is actually in our nomenclature, let's call it an overlap score. Overlap score, because that's always an integer and it means the exact number of bits that we're talking about. So the indices are maps to the input of where that overlaps are, and the score is just the amount of them. So we're going to also get the permanences, and we're doing this just so we can check. We've already tested get permanences, so we trust it. Okay? So I'm going to use it in my test. I'm going to get the permanences. I'm going to go through all of those permanences, and if any of them are over the connection threshold, then I'm going to count that. I'm going to add that to my count. So this is going to give me the total number of connections. And if you remember from the last episode, first the permanences are all just scalar values from 0 to 1. Thank you for the follow, Underground Cheese Weasel. Am I talking about you? No. My son heard me say something.
No, you looked at me and then were.
I thought you would think that was funny.
I wasn't listening. Sorry, say it again.
Someone followed me called Underground Cheese Weasel.
That's so wacky.
That's my son. He's sitting
Hello.
over there. Anyway,
Hi.
Underground, he's laughing too.
That's good.
Thanks for the smile, Underground Cheese Weasel. Anyway, so that's our total number of connections, and we're going to use that for our assertion because we know the overlap score cannot be more than the total number of connections. So that's one test we're going to do. And then we're also going to do this one additional test because the percent overlap should be similar, close to the percent of the input saturation. So if you've got 50% of your bits on in your input space, then 50% of the bits of your potential pool should also basically be on too. So the observed overlap percent of your total connections should be similar to the input saturation. That's the point there. So okay, so let's make this run and see. It was not as complicated as it seems. And I think, do I have one for compute yet? I think what I was working on was create overlap. I don't have a compute. So I'm gonna go even further with this, okay? Let's get stash, because I actually have an even more up-to-date. You didn't get that last test? Okay, let me explain it a little bit better then. Oops. I'll get to it in just a minute. What did I call this? SP overlaps? think so. All right. All right, yeah. So I've got even more tests that I want to explain. Okay, so this last bit here, where we say, so you get that at least, you get this one. It should at least, it can't be over the total number of connections. So if we look here, so we have an input saturation here. Let's say that it's 50%. 50% of the bits are on in this input space. If we look at one mini column, and we look at its what we're calling the number its overlap score, like the number of bits that actually overlaps with the space, and divide that by its total number of connections. So there's a bunch of connections here where there is no overlap. Statistically, since we're doing all this randomly, statistically speaking, this 50% should be the same as its overlap over its total connections. So that 50% should be the same. If this goes to 60, this should also be 60. It's just statistically, it should work. Does that make sense? Okay. You said sure. Hopefully that makes sense. It's not a super smart test, but it's a sanity check. It's close to, because we're dealing with random numbers. It's never going to be. I can't do exact. So I'm doing 10%, and maybe I could go 0.5. Typically, I run these several times. I'll try and get them the lowest tolerance that I can. Oh, I screwed something up already. So Pooler 82. What did I do here? Oh, I just screwed something up. Okay. Hey, Mark Brown. Talking about spatial pooling. Running some tests. Breaking some tests. I broke something in the spatial pooler. Did I change something here? Oh, this is weird. Oh yeah, I must have accidentally pasted like several spatial poolers in the same file. I don't know how that happened. Yeah, you know what? The spatial pooler is not that complicated, you know? Now we haven't talked about boosting yet. That adds a whole different... Boosting's more complicated than the Minicolumn competition, honestly. Okay, we have insertion error. Observed overlap percent of total connections should be similar to the input saturation. That's the test that I was just saying. So, so it's saying 0.8 should be close to 0.75. Because I halved my test tolerance, these failed. So I'm going to put it back to what it was. 10% test tolerance. Let's watch it. Unfortunately, these tests take a while. I think I could probably, I might speed them up a little bit, because like I did with the other one. Let's go, we only need 2 of these. This can be, let's go back to 0.1, 0.3, 0.6, 0.6, and 1 for input saturations. We don't want something with 0. And then there was another one here. This one's okay. But there's one that's nested that I could, so I can change this one too. Let's do this one, same one, 0.1, 0.3, 0.6, and 1. All right, just make sure that we didn't break anything. That should run fewer tests. I did break something. Unexpected token. In the spatial pooler again? Why does this keep changing? Hey David, is this you? I don't get this. My spatial pooler keeps getting stuff pasted into it. I don't understand how that's even happening. Save, close. I'm gonna make sure it's not me this time. Okay. Oh, you mean boosting is not biologically plausible? $55 tests passed. Well, there's got to be something similar to that going on because it doesn't work. Spatial pooling doesn't work without it. Okay. It doesn't work nearly as well, anyway. All right, let's go on and do, now we have everything passing up to what we have explained so far. Now we're going to do mini-column competition. And we're gonna walk through this and I'll show you how it's gonna work. Okay, so the assertions, here's where we're doing the competition, the compete. So let's walk up to this and explain this test. Okay, there may be other methods of boosting that are more biological plausible. The exponential boosting, I don't know. I haven't thought about that very much. I haven't thought about it at all. So let me know if it's something I should look into. Here's the thing: when we get to that, we could create different implementations of boosting or some way that makes more sense to somehow essentially distribute the semantics of the data. That's what we have to do. Better distribute the semantics of the input data. Okay, so we passed, but we're not even doing anything. So what I'm going to do is I'm going to loop through. So here we're doing another case during mini-column competition. I'm going to go through different Ks. All right, so the winner count is like a K. With one winner, with 10, with 40, with 100. I just wanted to have a few different options here. So each one, we're creating a spatial pooler with a different winner count because that's an option. I mean, that changes. That could be something we could change on the fly. I added it as a. Yeah, we could change it on the fly. I don't have to do it like this. I could create this. I'm just gonna leave it, but I could create this outside of the loop, and we could use the same spatial pooler every time if we wanted to. So with that winner count, with X or K winning columns, we're also going to test different input saturations. Let's do what we have been doing and just do 0.1, 0.3. I just want a representation, 1.0, that catches sort of the edge cases and a couple in the middle. 0 doesn't work. I already know 0 doesn't work. But actually, 0 should work here. Right, anyway. Okay, so the test is that the mini-columns with the most overlap, win. All right? Mark says, you're not saying it doesn't work. I just can't match it up to anything I've read. We don't know what the chemical signaling in brains is doing, so yes, maybe something like that that's not been documented. I think we're sort of banking on it. At least the concept of homeostatic regulation does seem to be accepted in neuroscience. I've heard that concept explained by more than one neuroscientist. Okay, so what we're going to do is we're going to call this function called compete. We've already written the code for this, honestly, when we wrote the overlap, calculate overlap. That's the main meat of this compete function. So we could call this compute. I'm just being really explicit. What we're doing here is we're creating winners. We're saying, given this input, run the mini-column competition and tell us who wins. So what we're going to do is assert that it's an array, that it is the same amount of winners that we expected. And then for each winner, excuse me, the winner is going to be identified as an object that has an index and an overlap. So we can say that this column is a winner because of its overlap score of whatever. So we're going to go through each one of these, and to assert that we've indeed chosen the mini columns with the highest overlap, we're going to go look at all of the non-winners and assert that our overlap score of this winner is at least as much as all of those non-winners. So this doesn't test tie-breaking. We haven't gotten to that part yet. Maybe we don't need to, I don't know. But this is basically the test. Does that test make sense? Because the code that makes this work is super. How is this happening? Something weird is going on here. David, I have to assume this is you because you're the one currently editing Spatial Pooler. And it keeps getting doubled up and tripled up in size. So I'm just going to keep undoing it and maybe you can figure out what's going on. Because I had this totally closed. It happened again just now. Okay, Dave, I'm going to kick you off of live share because and maybe we can try it again. How do I turn it off? Stop collaboration session. There we go. Okay, let me figure out what's going on here. Let me run the test and make sure that we're passing. Maybe, yeah, it could be a bug for sure. All this stuff, all this VS Code, these plugins that I'm using are really new stuff. You know, people like Microsoft is super like invested in this Twitch and the live streaming stuff, and so they're like encouraging their evangelists and their community managers to do all this type of stuff, which is very cool. Okay. All right, I'm gonna try and live share one more time. Your VS Code has been minimized. Well, let's try it again. So I just killed the session and started it over. Okay, so the compete function. Here we go. This is the meat of it. Like, remember, we've already done the calculate overlap. So for one mini column, this is how we get the overlap. It's not too complicated. All we're doing is we're making sure that the input bit's on and that our permanence for this permanence is above the connection threshold. Then we're going to say yes, there's an overlap to this input index. When we compete, we are going to loop through every mini column index, and we're going to create an object that includes the mini column index and its overlap score. Okay, that's it. And the rest of it's just sorting. And the sorting is basically the competition. So we have our list of mini column overlap scores, and we sort them, and we're going to say if the length of one is bigger than the other, blah, blah, blah. And so essentially by the end of this, we have overlaps. We have our overlaps array sorted by overlap score, and we can just take the top winner count off the top. And that's all we're doing. That is the mini column competition. That is what I drew on. That's what this is. This K-winners competition is that little bit of code that we just looked at. This is it. Calculate overlap and compete. And it works. And at this point, with this test, I'm pretty happy with this test. This is now we're not doing boosting. Remember, we're not doing boosting. We're not doing local inhibition. We're not doing topological data. But this is but this works. So what did I change here? All right, I changed. So this is the version we're gonna go forward with. I am going to actually create a release, create a pull request, and we're going to release this as is, because I think this compete is all that we need right now. Because remember, the next thing we're gonna do is the mini column competition. So we're just finishing up this bit. We've already done this bit. What we're writing this for is so we can do the mini column competition. We just wrote the code for this, so we can start visualizing this. And this is going to be fun. So that's what we're going to do next. But first we have to release this spatial pooler code, and we're going to inject it into the React application as the data source for all these diagrams. The GitHub link, for simple HTML, there's a link to it here. BHTMS, if you go to this README, simple HTML, boom. That's where the spatial pooler is. That's where I'm going to create this pull request at as soon as I commit. Tests, git push, origin. Oh wait, git commit. What did I do? I changed the some of the test conditions. Updated test conditions for saturation etc. Okay, git push origin sp overlaps. That HTML YouTube playlist is gold. Thanks, man. Appreciate it. Those took me a long time to put together, but I learned a lot about HTML. Okay, so did I push it? Yeah. So now I should say that this is ready to go. I'm gonna create a pull request, do a quick review. This should actually run tests in CI. Got their new spatial pooler. We have a compete function. We have a get permanences function that is now idempotent. Here's some of our changes to our tests. I know it's a little hard to see, but all this looks fine to me. I think there were some white space changes too. And then the new test. Permanences are always the same. Then the overlap calculations. And then the mini-column competition. All right. I approve my own PR. Is that, you need to leave a comment. Okay, I'm not gonna do that. So this is running right now. Let's make sure that the tests pass. I don't want to allow anything in that breaks CI. Here they go. Some of them I had to put a timeout on because some of them run too long. So I wouldn't be surprised. There we go. Great. 71 passing tests. Mini-column competition seems to be working. Let's merge it. Confirm merge. Now, what I'm going to do is create a release. I sort of like to do that off a different thing. So I've already got a 020, so I'm going to create a 021 package.json. One. Okay, git add package. Git commit. Release 0.2.1 mini-column competition. Okay, git tag annotated 0.2.1 sp mini-column competition. I probably should just named it 021, but whatever. Git push origin, no, upstream 0.2.1. And I'm not gonna create a PR for this. Git push upstream master, whoops, master. Thanks Falco for pushing people to the forum. Yeah, if anyone is interested in more of this type of work, go to our forum. There's a lot of great discussion there about this. npm publish. That should do it. So then we're gonna go back to building HTML systems. And so I'm gonna cancel the other live session. It doesn't even seem to be on anymore. Whoa. Okay. Now I'm bringing this one in. I'm gonna live share this. So I think the other live share just died. And now this is our current live share session for building HTML systems. So the first thing I gotta do is update my package and say I want simple HTML 021. And then npm install. That should give us one updated package. Before I get too into this, I'm probably gonna take a break. Been going for over an hour, so let me take a break. And then what we're gonna do is we're gonna take this new spatial pooler, we're gonna put it into our, let me first, before I do that, run the server and share it so you guys can get access to it. Share server. There you go. So now, this is amazing. If anybody's new to this VS Code Twitch thing, if you're running VS Code, just stack more. Why do people come in here and just say, stack more layers, bro? You know what I got to say about that? Hold on. Sound.
Bruh.
Dean likes that sound. Bruh.
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 Seriously. Bruh. I should let you guys know that there are sounds. you can make people, you can say bang sound. This is my favorite.
It's puzzling. I don't think I've ever seen anything quite like this before.
Anyway. And then of course, nobody's ever used this one, but this would be a good one. Whenever something pops up and it's confusing. How did that happen? Stack more layers, bro. That's exactly it. Okay, let's. I'm gonna put this on the room loop, and BRB, room loop 2, BRB. There we go. Taking a quick break. Stick around, you guys. We're gonna do more cool stuff. We're gonna make this next, and it should be cool. Just buy an Apple stand. Did you hear me on Twitter complaining about that? I want one of those displays, but are you kidding me? How in your right mind can you ethically create a display stand that costs $1,000?
Complaining about something?
Yes.
Nice.
I love to hate Apple.
Hates Apple. Hates Apple. No plugs.
Right there.
What?
Look at that giant
Look at this.
wall of plugs.
Look at this thing.
This.
It's measly and small. Wait. Oh, oh that's perfect. Oh yeah, that's perfect. Thank you.
I should probably check my email. Oh, you know what I want to do is check my guitar. I don't know if I told you guys yesterday, I bought a guitar. I have to go find, there's a tracking page for it. And it hasn't been updated in 2.5 days, and it's somewhere between Illinois and California. And it's driving me crazy. Come on, man, where is it? I gotta log in and everything. It's a Strat. Yes, it's a Strat. It's an American Fender Stratocaster. Oh, you're a Palm Pilot fan, FD God? You probably are you following because of Jeff Hawkins? He's on the stream, you know, on research meetings. Any of you guys follow our research meetings? We do at least one a week, usually more. Yeah, no update on my guitar yet. Don't worry, you'll see it eventually. All right. I'm gonna finish eating my croissant before I start. How did Jeff get into neuroscience? Yeah, if you read On Intelligence, that'll tell you all you need to know. Where is my book? Here it is. This is the book that introduced me to Jeff Hawkins, and I'd never heard about him before. And I went to the bookstore specifically to look for books about intelligence and how much did we know about how the brain worked, and found really little at the time. It was like 2006 or something. Found very little. Like, we didn't know much at all. And I was surprised, but this book was enlightening because it made sense to me. Like, it was like, oh, at least somebody's like coming up with some broad theory about how cortex works. That he's been at this for a very long time. And he's currently writing a second book, Jeff Hawkins. I hear about it all the time. I've actually read half of it. It's going to be good. It's going to be good. Yeah, it was all about the predictive aspect. That was not something people thought about. The predictive brain, the fact that the brain is always predicting what's about to happen next was a bit of a novel idea in the world at that point in time. What's up?
What's the internet?
What's the internet? Did you get disconnected?
No, this one isn't.
I'm gonna give you the one I'm not using.
What? That's wacky.
We should both connect to that one.
Yeah, I believe I'm connected to that one.
I'm taking a break because I don't think the next part that we're going to do is going to be easy. I was lucky, I think, finding this book when I did, because there's a lot of other things you can look into and spend like a whole career. Like, there's neuroscientists that spend their whole career studying one minute sort of area of cellular interactions in one specific part of the brain, and they add a bit to the whole picture. But I think for the longest time, most neuroscientists were sort of doing it like that, and it was not in fashion to put together big theories about how things worked together. This was before the causal revolution as well. So people didn't like to talk about causes of things. Yeah, what they said. It is obvious in retrospect. So when I talk about temporal memory, which is the TM part of HTM, we're not even talking about that yet, but this spatial pooler structure that creates a space for the temporal memory to sort of run within. Hey, Falco, you said last week at a Numenta party, a neuroscience researcher gave Numenta a great compliment. Who said that? I don't even remember. I missed it. Was that on the live stream? How do we play those what if games? Yeah, so I think that what we've learned about space and how space is represented, I think, and how you can apply that to conceptual knowledge is going to be a key to that. Wow. All right, let's get some. Let's get back to work, I guess. Hold on, what happened here? Okay. Make sure I'm not missing anything here. Okay. The site won't be in read-only mode for long. It does that sometimes when it backs up, so just give it a few minutes. If we're talking about the forum. Let's go to here. That's what I was going to do. So here's the application that we're building. Here's the spatial pooling page. This is what we have done so far. We've got a visualization of a combined encoding of some input. This is a scalar input moving with the context of time, 4 dimensions of time. And then we've got our potential pools, which, let me make this a little bigger. We've got our potential pools. So this stuff is, the spatial pooler should be doing this, what we just were coding, but it's not. We sort of have some local code doing it, so we're going to change that. We're going to put the spatial pooler in place, and we're going to get these from the spatial pooler. And again, here in the permanences, we're going to put our spatial pooler in place. It's going to be the data source for these permanences too. And then, like I said, we will get to the fun part, which is the Minicolumn competition. And that's going to be fun because we're going to add some mouse interactions. We're going to have 2 different displays. We're going to show the connections, potential connections, connected synapse with no overlap with the input. It'll be an interesting visualization, I think. Pretty involved. One of the, probably the most involved visualization I have planned so far. So we're going to try and do it well. But for the first thing, I want to put the spatial pooler in place for these things. So we're going to go to the code. Like I said, I have already updated to simple HTML, so the spatial pooler should be available. And so let's go to potential pools first, because this is where we're going to want to use the spatial pooler. We're already importing these encoders. So I think I can just say const spatial pooler equals simple HTML dot algorithms spatial pooler. I think that should work. So first of all, this is not what I want to do. Okay, forgive me here. That's not what I want to do. I want the spatial pooler to exist on the spatial pooler page. So after my React stuff, these are inputs. I'm gonna put my spatial pooler right up top. And let me grab it from simple HTML. I'm doing my imports wrong, just a sec. Okay. So this is a spatial pooler class. This is the spatial pooling React diagram, or React page. This is like the whole page. It's a React page and it has state. So right now we're not keeping state for this potential pools. We're passing data into it with props.data. And we're getting that data from sort of an outer component, what David called a high order component. So this is going to change every time. What I really want to do now is, instead of passing this in to change every time, because this same thing is because these right now are doing their own calculations. They're basically running the spatial pooler logic internally. I want to keep the spatial pooler outside, so I want to intercept this data when it updates. Hey, David, you'll be back soon? Okay. I need to figure out, here's my update rate with scalar data. I need to figure out how to intercept this scalar data when it comes. And so I think it's, since it's going to be a property, oh, here's the start data. This is coming from this high order component. Where did it go? Where did it go? Out here. With scalar data, right? So it has a start and a stop. And this is what's actually creating the random data. So the idea is the page is going to have, it already has this random data creation bit. I might not have exported the spatial pooler properly from simple HTML. Just a moment. Here, algorithms, I think I have to like expose it from index, right? Yeah, shoot, I forgot to do that. Algorithms. So we're gonna have to version another, sorry. That's all right, no big deal, this happens. SRC, algorithms. Spatial pooler. Okay, that should work. I have my comma there. And I'm gonna have to rev my version, 2.2. But we're in a 0-point version, so no huge deal. Where are we? Okay. So I got to do the same basic thing: git, add, index, and package. Git, commit, release 0.2.2. Git tag annotated 0.2.2. I'm just gonna. Whoops! What did I do? Git tag A, not B. 0.2.2. Okay, git push. Upstream 0.2.2. It's a big process. Git push upstream master. I should write a script that does this. In fact, I have on different things for different projects where I have a dependency like this. It just only takes a couple minutes, but hopefully we won't have to do this anymore. Okay, of course, we will now need to update our dependency on simple HTML in package to 0.2.2. Whoops. 0.2.2 and reinstall. Should have an update. Now, hopefully this import will work. Get out of there. Get out of there. Am I still in simple HTML? Here we go. So hopefully this works now. We can go simple HTML algorithm spatial pooler without a problem. Let's run it again. Building page, okay. There we go. Okay, so now we need to get this spatial pooler. First of all, it's not going to be part of the state, but it is going to update the state. It needs to update the state. So first of all, the state that we need, what we want to display in those visualizations, first is potential pools. Is just pools. So we'll have something called potential pools, and then we'll have something called permanences, pools and permanences. As those update, and they shouldn't, the pools aren't going to update. The pools are like a one-time thing. If you recreate the spatial pooler, I take that back. We might change parameters of the spatial pooler. If we change the input space, then we do have to update it. So we're going to have two more global things. We'll call it potential pools and permanences. And these are originally going to be undefined. So we're going to calculate these given an update of scalar data every second. So so what's going to happen is our property called this.props.data is going to update every second, and I need to run something in response to that prop changing. And this may be, I think this is a React question. Maybe it may be in component did mount, component did update. Maybe not. So when I call start data, I'm going to go back to the higher order component here, because it gave us a function called start data. Yeah, start data stop. So that sort of was my access to it, and then the data gives us this data. So what I have to do is figure out, so this is just calling set state. So I need to respond when state changed. So I'm going to do a Google search here. React JS state changed event. React native, I don't know what native is. React JS state change, not 3D. State change listener. That sounds right. Listening for state changes in React JS is sort of what I want to do. Component did update. That's not really, I don't think that's the right one, because that, maybe it is. So that's the one I'll try first. I'll try that first. It might be right. So we're going to do this first in potential pools. Actually, no, we have to do this in spatial pooling. So we have component did mount, component did update. Okay, so if this is right, I'm just going to console log my data, this.props.data, and let's see. Take out these stupid semicolons. Okay, so if this is right, I should see some logs here. Yeah, so it's login data and it's different every time. So there we go. That's it. That's all I need. Okay, so now I'm not going to pass this data in anymore. We're going to pass, the data we're going to pass here is no longer potential pools. So we're going to take a lot of computation out of potential pools, because remember that was doing both the potential pools and the permanences were doing encoding, and they were creating the input space representation, and we're not going to do that anymore. We're going to do that outside. That's one of the reasons why I sort of didn't do it then. So potential pools is what we're going to use as a data source for this, and permanences. I'm not even passing data to this. I'm not even passing data to permanences. I wonder why. It seems like I would set up initial connection strengths. Oh, because it's doing all its own calculations. Okay, so I'm going to pass permanences in. It's not going to do its own calculations anymore. In fact, none of this stuff is going to be here, because this is going to be part of the spatial poolers configuration now. So all that including connected percent, because that's going to be something that's going to recreate the spatial pooler. Minicolumn count also, input space size. I don't think we need any of this stuff, because the spatial pooler is going to determine all of that stuff, right? I think this is all we need. Data equals this.props.permanences. All this is going to care about at this point is just taking that array, which is an array for each mini column, and basically creating these diagrams that I broke, that are all broken right now. That's okay. We'll get to it. Okay, so let's go. So now we need to run some logic here. Now that we have updated data, we need to basically do what we were doing in potential pools when we get updated data. So all of these encoders and these days and this crap, we already have simple HTML. We're going to take this out. Oh, actually, for the potential pools, I have to do this. No, I don't. I don't have to do this at all. Yeah, I don't have to do that at all. Never mind. I don't need these encoders. here. I can grab my encoders. Oh, these are not, this is what I want to do here. This is for encoding, this is for spatial pooling. Okay, so I'm going to use these encoders in the same way I was going to use them here, where we get component did update. Set up initial connection strengths. That's, I think, what we want to do. And this is now always going to call update. And never send previous props. I don't know why it's doing that. This is simply just always going to call this update, I believe. Render minicolumns, render permanences, set up initial connection strengths. That's the part we don't need to do anymore because the spatial pooler is going to be doing this. So all this jazz, the spatial pooler is going to do, and we're just going to call it to get the permanences. So we don't want to do this anymore. That's what we're going to do up here when things actually update. So I'm just putting this here just as a reminder. So when we get, so let's create a spatial pooler. Let's just call it SP equals new spatial pooler. And we're going to use basically these our state as its parameters. Is this the right? Let me just make sure that I'm using the right thing. It's on my tests when I created this, I'm gonna steal. Yeah, let's steal this so I get all the names right, all the keys right. Take that out. Take that out. Take that out. Okay, so the input count. The input count, I don't actually know the input count because I have to have the encoders to know the input count. So I have to do the encoding bit here first. Before I can create the spatial pooler, I have to encode a bit of the data somehow. So for right now, this may be perfectly fine to do this way. We can create a new spatial pooler every time, and then we'll iterate on that. I know that sounds silly, but I'm happy to iterate on that. Because we have to have these encoders that will encode the data, and that had its own function, right? So here's the encode function. So this, we're gonna do completely outside of this. We're not gonna encode in potential pools anymore. We're gonna encode at the spatial pooler level. We'll put it here. Okay. Props. Okay, so this encoding should come from, yeah, this is right. I think this is right. Props, data, time value. I think this might still work. And just create an encoding called this encoding. So every time there's a component did update, call encode. Assuming that we have access to this.props.data and it has changed, we can create a new spatial pooler. The input count is going to be encoding dot length. The SP size, let's just make it 2048. I don't know. Hard code it for now. Hey David, I figured out how to run code when the data updates and component did update, and now I am just trying to put in, like, collect the potential pools from the SP once I have it set up properly. Okay, so connected percent, I'm calling, I don't even have that set right now. Okay, I'm gonna hardcode stuff initially, and then we are going to update it as we go along. Winner count 40. I don't know. Okay. Const pools equals sp dot get potential pools. Thanks, FD. I will be live again next week for sure, sometime. Maybe even tomorrow. I don't know. It depends. Const perms equal sp dot get permanences. Okay. So these. Oh, this is what I want to do now. I want to say. I want to update my state with these objects. So I want to call set state. Maybe I don't, since I'm in the middle of component did update. So am I going to say if data has changed, then don't recreate? No, I'm intercepting the data change so I can do the encoding, create the spatial pooler, and then call the spatial pooler to create the pools and the permanences instead of the diagrams themselves. Fire truck. Hello, fire truck. I like to show the fire trucks. Yeah, so, yeah, Discord is up, but I'm not quite listening to it. I can hear you guys. So this is going to create pools and perms, and these are the objects that now are my state that I want to update. So what really updated was the data from the outer high order component, and now I want to update my local state, which is going to then update these things, which are the data sources for the diagrams. So I think what I can do is say this dot set state, excuse me, potential pools, well, not exactly this, because it's, but something like that, or this. Yeah. And the same thing with permanences. Does this seem right to you? Activate my, yeah, sure. I will. Let me put my headphones on before I put my mic on. Now I'm jamming. All right, I'm on. Can you hear me? You can talk it out. Okay.
Yeah, can you hear me?
I can hear you. Great.
So, so you want to create a new spatial pooler anytime component update?
No, but for now I am. I'll fix that. I'll fix that later. For right now, all I want is, this is definitely called whenever there's new data from the automatic generator thing that does with the with scalar data one. So I want to encode it, and I want to get the data from the spatial pooler, and then these are the states that I want to automatically update. Want to be automatically updated. I think this might work, right? I'm hoping it works.
You can collapse those two set states into one object just with both of it.
That's, of course I can. Okay, and then I had bounded scalar encoder is not defined. Like, do something wrong here. Bounded scalar encoder. Oh yeah, that's within. So I still have some things to fix in permanences, or potential pools. Excuse me. All right, because I took encode out. So this is all broken right now. So I need to update this whole component. So we're not going to do any simple HTML stuff. There's no potential pool stuff. This is all gone. This is all going to be in the spatial pooler now. There's no encoding. There's minicolumns and selected minicolumns. This is essentially the data. Let me think. So I don't need this. update did mount. Will not encode. We're not going to be setting up the potential pools. We're essentially getting them. We will have them. So there is no setup anymore. We're just going to assume the data is there.
So what's creating that combined encoding now?
I have to send it in.
Oh, it's that high order component thing we made, right? Yeah, okay.
Well, yeah, I created the component here, this .encode, but really this should now be part of the state that gets sent to, like, the diagrams need to update that based on this. So this is going to be new state. So I'm going to have encoding here now. I'm lifting a bunch of state right now so that I can share them across a bunch of diagrams that I'm going to work with. So, because I need this spatial pooler like right at the page level, and it's just going to be running, and as it runs, it just updates these page variables that update the diagrams. Does that make sense?
Yeah.
Okay, cool. So the encode function should set a state. So instead of this .encoding, this should be okay. That's the result of encode, is setting a new state. So every time we update, we have a new state. This sets a new state. Actually what I'll do is I'll return this. I'll return the encoding here, and then we'll update the state all at once. Yeah. And then we'll just add this as a part of the set state. So that makes more sense. So this is exactly what I need to update every time there's a data update. I got a new encoding. The SP potential pools will never change. We'll deal with that in a moment. We'll lift the SP up out of this update and just, you know, reset it, or set what it needs to be set as data changes, because we shouldn't be creating one every time. This is just the easy way to do it right now. Okay, let me just review here. So when I get down to the potential pools, it needs, so this is going to be more than just data. So we're going to give it potential pools, and we're going to give it an encoding, because we want it to display that encoding too. Encoding. But this is my own state, right? I send my own state. Does that make sense? Am I doing the right thing here? Yeah, it is, okay. Yeah, encoding potential pools, that's what I need there. I'll deal with permanences in a bit. I'm just gonna comment it out. Let's try and get this one working. So if I just have an encoding of potential pools, go look at potential pools here. I'm not sure this is valid anymore, but we'll see. So on update, I don't have props.data anymore.
Are you supposed to just pass the spatial pooler to the potential pool?
No, I don't want to do that. I just want to pass it only the things it's going to be displaying.
Okay.
I want to run the spatial pooler at the page level and just give away and just expose just the state to the diagrams that need it. So I don't need to check for data anymore, but I do need to go through here and make sure that anytime that I'm going for data, anytime there's a, where am I getting, I think I've already removed it. This .minicolumns. Okay, so anytime I'm calling on this minicolumns, this should be this props potential pool, I think. I hope. So let's try and find out. This mini columns, selected mini column. Yeah, this, but so that's not quite right. Whoa, what was that? This that potential pool. So my data structure's changed a little bit. So things aren't gonna be perfect until I figure out exactly what all this stuff is. This should be, I shouldn't have to say dot potential pool right here. This should be the right thing, I think. And where else are we saying mini column? So this should be, again, not this. It should be props dot potential pool. Where else do we have mini columns, mini columns, mini columns? I can get rid of this. Selected mini columns still is necessary. Mini columns dot length, there's another one. This should be props dot potential pool. I don't know. Mini columns. Okay, that was it. Okay, let's just see what error happens now. Cannot read length of undefined. This is on 78. Here. Okay, so props.potential pools, right?
That's, yeah, you were initializing it as undefined.
Yeah. Oh, I was initializing it as undefined. Did I call it a pool or pools? I did call it pools. And it is initially undefined. So I do have to put a check in to make sure that we don't try and render anything if it's undefined. So I'll just say if this dot props dot potential pools is not undefined, I'll render. And then everywhere I've got potential pool should be potential pools. Potential pool should be potential pools. Is there only one place? I guess that's it. Oh no, there we go. There we go. This is the, I was just writing in the wrong frickin' place. Okay. Let me undo all of that because I was in the wrong file. And let's just close this file. I don't need to have it open right now. Okay, so in the update function, first of all, let's do this replacement. Replace all. Okay. And then in the update, that's what we're going to say. If this dot props dot potential pools. I think I could just do this. If it's probably fine. If there are potential pools, do it. Encode. So scalar encoder. This is in spatial pooling 58. So I didn't instantiate my encoders properly, probably. This dot scalar encoder. Yeah. Oh yeah. I used to have all that stuff. Let's look at the diff here. So these encoders, but I don't want this. I don't want this. I don't want any encoders. So if anything's referencing an encoder, it shouldn't even be there on 58. Oh no, this is in spatial pooling. Okay, sorry. I just have not properly instantiated them. So let me go swipe that code that instantiates them from potential pools, which was here. Yeah. So this needs to be part of the spatial pooler now at its local state, these scalar encoders. And we could eventually add page level controls for them. But for now, let's not think too much about that. Okay. Off color is not defined. This is the spatial pooler 70. Oh, so I'm actually deciding colors here. It's not really what I wanted to do. Okay, but for now, I'm gonna do it. For now, we'll grab off color, combine color from here. I'm not crazy about this, but well, for now. Just want to see it working. Okay, length. So we don't have it encoding at 56. we do not have an encoding, and component did update because I haven't set the state yet. Oh, I just need to grab it from the local one, that's all. Because I haven't set the state yet. I should fix that. Again, it's an encoding problem. Render input space 43. This is in potential pools, is looking for an encoding. Okay, potential pools, render input space. It is looking for an encoding. Right, because how am I passing it? I'm passing it in encoding directly. So it's in this.props.encoding, I believe. If there's any other this.encoding here, and there is, I think I want to replace it with this.props.encoding. Okay. Because that's passed in from the parent page. Okay, something's happening, but so the stack overflowed. We're in set state, so I'm recursively setting state, right?
Yeah, you're setting state, and then it's calling the update again.
Okay. So this is in spatial pooler. Should not be happening anywhere else. So this with scalar data setting state, and then within the component did update, I'm setting state again, which is going back.
So do you want those as local class variables rather than state?
As long as I can pass them to the child components, that's fine with me. I just want them to. I just want to be able to. Oh, I could just make them props. You're saying, or just local this dot whatever. So I could make this dot encoding, this dot potential pools.
You can, but it won't cascade that down unless you're updating state. So
well, if this is called every time with scalar data updates. Oh yeah, I see what you're saying. So what do you suggest then? Because it seems like these should be. Yeah, so like the data updates, and then I update some components based on that, and then it's back to the.
So you would have to like check like against previous props to see if what you're changing is a potential.
Oh, I see. So I should only run this if what's different is the data.
Yeah, basically.
Okay. So I can get previous props here. And say like if is there like a so what I really it's just the data, so I can say I'll just check the scalar data value, and if it's different I'll so if this dot state dot data dot, now I gotta go look and see what did I actually call it, what are we actually setting? It's just data.
It'll be props.
Value and time. It'll be props. Okay. Yeah, props. Shoot. Okay. Dot value. Okay. So if the data has updated, if it's not the same as previous props dot data dot value. The data is updated, so I'm going to update further state. So now when this comes through, the data will be the same and it won't reset the state. I hope.
Right.
Let's see. Oh, yay. Oh, yeah. We got it. The spatial pooler is running this logic now. So good. So let's change the connection threshold. Or the connection, let's change something. Where am I creating the SP? Is it 2048? I think it is. So let's change this to 15% Thank you, Falco. All right, so we're seeing it working. That's great. Finally, a good use of the sound effects. So the spatial puller is in place for this one. Now we need to put it in place for permanences. Okay. So let me take.
Unfortunately, the sounds do not sound in the Discord.
Oh, they don't. Yeah. No. I don't think they would. I don't know. Maybe there's a way to do that though. I'll figure it out some other time. Okay, so we're not using this combined color. Potential pool color. Yeah, just this. We are using off color. So there's some refactoring I'm sure that we could do here, but let's just get this working. And then we'll come back. Okay, give me a break here. I need to use the restroom. So I'll be right back.
Brains.
Oh, hey, thank you for follow, Led Rolika. Is that what it says? Led Rolika? I appreciate it. Dean, you getting hungry?
Huh?
Tell me when you're hungry.
Oh, are we gonna go down to the buffet?
I don't know.
I really want to do that.
You really want the
That place
buffet?
is good.
It's like the cheapest Chinese food you can get.
I love you.
Don't knock this over. I want to heat up some water. When this thing goes off, it kicks off the switch and you have to turn it back on.
Why?
Because it like overloads the circuit.
Falco, you on voice?
Yes?
No, just checking.
Oh, okay. But I'm mute because I don't want to make
Well.
strange noises.
The cat's away, we can play now. Looks like you're getting close.
Bitking, I wanted to ask a question, but I'm too lazy to write the whole post.
Interesting.
Okay. I heard
Okay. I think it's good. Go.
yeah, okay. I overheard a podcast with Patricia Churchland, and she said a lot of interesting things. But one of the things she said, made me think of you, is that she said that one of the neurotransmitters, oxytocin, evolutionary has been reappropriated. It existed long before Mambo exists, and it has been reappropriated later, apparently. So something that we should check out.
This is not a surprise. If you check out most of the neurotransmitters, they're reused all over the body again and again. For example, a great many of them are used in the gut. So this is not a surprise that the body, the coding for it that's in the DNA, keeps finding new and interesting ways to paste it into function.
But then it used to exist and not create the feeling of the so-called cuddling feeling. That's strange, isn't it? Well, it's not that strange, but so that means that serotonin and dopamine and all those other neurotransmitters did not produce.
I did a link for a question earlier. I can't remember who I was responding to, where maybe it was you. I don't remember anymore. But I did a partial list of the neurotransmitter chemicals and the neural messengers I was aware of. It was a very, very long list. I think it ran 30 or 40 items at least. So there's a bunch of stuff the brain is using.
Yeah.
And they're not all the same mechanism. Some of them are what you would call amines or whatever. Some of them are proteins. Just that there's a huge variety of chemical messengers. And some of them work as short term, some are long term. Some are very selective in what parts of the brain they activate. The old part of the brain releases those, they go out in the body, do all the things that they do to the body, and the body responds, the heart rate goes up, you sweat, you do this, and then you sense that the effect it's having after it's had it. It's kind of spooky because that old brain stuff, you can't, since it doesn't have any presence in the cortex, you cannot actually sense that it's happening, but you can sense the effect of it happening on your body.
Yeah. Yes.
Damasio, go.
Well, the emotional effect, the fact that you feel happy with when serotonin floods to your brain, could be considered as an after effect as well.
I think it's more of a side effect than it is a direct effect.
Yeah.
There's a book that I have queued up. I read it long ago, and I've decided I'm going to read it again. It's The Feeling of What Happens. I think it's Damasio's book. I could be wrong, but that's what I remember. So that's actually very pertinent to what we're talking about, and I'm looking forward to reading that again because this is a current topic.
Yeah, Antonio Damasio. Yeah, you're right. Okay, I'll look it up. Thanks.
I have it sitting on my nightstand waiting to be read, but it's not alone. There's a there's a stack of books there competing for attention. In my personal life, I have a rebuilding project in our house that's highest priority, and my wife will not forgive me if I don't work on that. And for my job, I travel. Like right now, I'm sitting in Amman, Jordan. This week, I was teaching people how to weigh airplanes. So
okay.
it's my job. It's what I do. And next week, I'll have to catch up on all the work that's sitting on my desk waiting to be done. But I'm planning a little later this summer to get busy, and I put a post on the diagram for the brain, and I would like to take that and some other loose posts I have and start organizing that into more of a book form where it's more organized and the material flows to each other rather than just being a bunch of loose bits and pieces. I don't know if it'll be the same as on intelligence, but it would be nice to organize all this stuff and see how much of a complete picture it puts together when it's assembled properly.
Yep. I think Matt is ready.
Okay.
I definitely think we need more of the big picture, sort of people trying to put the big picture together. It's a good initiative. I pushed this to a remote branch. Anybody wants to see it? I'm not going to merge anything yet, but because there's definitely something I hate right now. There's something totally wrong, and it's that the potential pools change at each time step. That's wrong. The potential pools don't change along with the input. They're established initially upon SP initialization. That's because we're creating the SP every time we get a data update. So we certainly need to hoist this out.
There's your fire truck limping home without its siren.
Oh yeah, I forgot. I wasn't even showing my screen.
Well, it was real loud a minute ago.
Yeah, those guys are super loud. They go right by. So, okay, so we got to get this SP up. The SP really needs to be a local component. So we'll create it, and this state we'll create it initially and make it undefined, and we'll only recreate it when absolutely necessary. So we can do SP, and we'll just create it undefined initially. And certainly can't, we're not going to do this here. So there are going to be some times that we're going to do this. We're only going to do it if someone has changed something where it would have to change the way it creates its potential pools. And permanences, honestly. So if anybody changes its size or its connected percent or its connection threshold or the winner count, essentially. Those are the only things that we care about. So we're gonna have, and I don't even have a winner count in here yet. So there's only these 3 things at the moment, because the size we're sort of hard coding for now. So let's check just for those things. So we're always gonna create a new encoding, and we're gonna say if, and only if we have new information of one of those 3 components. So this is sort of a nasty if statement, but if this dot props dot connected percent, are we using the same thing? So first there's connection threshold. Let's do that first. Connection threshold not equal to previous props dot connection threshold. Or let me do this. Or I'll do it like that. This is all personal preference. So. Hey, thanks for the follow, Joey. Appreciate it. So if the connection threshold is different, I'm gonna try and arrange these even sort of in the same order. Threshold percent, connection distribution, which is actually called the Bates. What did I call it in the potential pooler? The Bates independent variables. Okay, so we got a little bit of naming problems here. We'll deal with that when we get to. So if I'm not even adding that, but we're going to add that too, and we'll use this dot props dot connection distribution. Okay, so that's the other one. If connection distributions has changed, so if this is not equal, or if that's changed, or, and the last one, just wanted to reformat, so I guess I'll let it. Let's put this back in the right spot. Up. Connected percent is the next one. So this is going to be 0.85. Sorry about the noise. I don't know what's going on outside. Sounds like school children. Connected percent. This is just like programming minutia right here. Connected percent. So if any of those have changed, threshold, distribution, or percent, and this again I have to get from the right place. Not 0.5, we're gonna get it from there. And then what else? Threshold, distribution center. Oh, I forgot about that. Yeah, so that's also gotta change. Which I'm calling distribution center, so at least I can use the same thing. So that's yet another thing we need to add. This dot props dot distribution center, and another or this dot props dot distribution center, props dot distribution center. So if any of these spatial pooler parameters have changed, we're going to create a new spatial pooler. And the winner count eventually will add. For right now, I'm not. And the size too. We can change those and we can add them whenever. But I think that's the only thing that I have baked in right now. Distribution center, potential pools, permanences, and encoding. So these are calculated. This is a UI state. This is SP state. Calculated upon data change. Say automated data change. And this is just a UI state, right? So just put a little bit of labeling in place here. Okay, so I'm hoping this might work. Usually I've touched too much code for this to work right off the bat. SP is not defined. Oh yeah, okay. Where is that? 76. So I'm calling SP here when I need to be calling this.sp. So I hope this works. I hope I can say this.sp equals and reassign it. This.sp. This.sp. That should work. Cannot read property, get potential pools if undefined. So this is on 76 again. So we don't have an SP at this point, likely because we never created one in the first place. So we always have to create an SP on startup. So on mount, we certainly want to do this. So before we even start the data, ooh, see that? Okay, so this is tricky. So we're not going to have an encoding on mount because we're not going to have data on mount. What we really need, this kind of sucks. But what we really need is this is a non-data update. This is a data update. Data. Oh wait, no. Excuse me. This is the data update. Automatic data feed update. Okay, so we do a new encoding, and this shouldn't happen here because we're not setting the data at the same time as we're setting the other things. So this is more like parameter updates. Everything else, if it's not a data update, it's a parameter update because the data is only updating itself. We're not. If we get it, yeah, I think I can rely on that. The data is updating itself at an interval. Anything else, any other state updates that are happening, they're going to be happening on, without a data update. So I'm going to have two conditions. One where there's new data that needs to be encoded and then the states need to be updated for the diagrams. And the other condition where there's some parameters that users have tweaked or something and the spatial pooler potentially needs to be recreated. I think that's fair. So one problem with this is we can't create the spatial pooler unless we have an encoding. And we don't have an encoding unless we've had a data update. So maybe it's easy enough to just say if this dot, no. Yeah, if we have an encoding state, if this dot state dot encoding, then we're going to create the spatial pooler because we've seen a data point. And I just have to make sure that this is right because this is here now. Okay, this might work. So the first update we get, let's say we're still trying. So now we're at 63. And SP is undefined at 63. We're in set state. Because we can't set that state until we've created the spatial pooler, obviously. So we have a data update. We got a catch-22 here because we have to have data to get the encoding because we have to have the encoding length to create the spatial pooler, and we have to have the spatial pooler to update the potential pools and permanences. But I still need a condition under which if only parameters change, we have to recreate the spatial pooler. So we're basically going to have two places where we create the spatial pooler, and we're simply going to, this is always, if there's a parameter update, we'll always have an encoding because we will have already seen data because data streams immediately. Okay, so I'm going to depend on that. And all I'm going to do here, this is going to be a little bit redundant, but I just want to make sure that it works. We're just going to say if there's no SP, create the SP. Now that we have it encoded. That is if there's no SP, create it. All this stuff should have values. And then really, I'm gonna offload this to another function in a moment, but I just want to see if this is the right path to be going down. So encoding is undefined at 64 because I'm not looking at, because I should be looking at the local encoding again. Okay, I'm starting to see where this is going. Okay. So now we have 0 potential pools. Okay, so something's odd going on here. So this is not the potential pool, set state, potential sp.get potential pools. This seems to be always, or maybe just never being called. If potential pools were originally undefined, it might display nothing like this. All right, well let's dig into this right here. Let's just see what's going on. Okay. So we've got an update. Previous data is nothing. So this is probably a data update because data has a value. So we've got a data update. First off, data update. We're going to encode it. It encodes. Here's our encoding. If there's no SP, which there's not, then we create an SP with an encoder length, but we don't have a connection threshold, of course, because that's undefined. Our props. Oh, okay. So I think I just need to provide. Well, this should be. Oh, I'm looking at props. I should be looking at state. That's all. So this is a state, not a prop. So let me just grab this. These 3 things that I'm checking: connection threshold, connection distribution, connected percent, even distribution center. Isn't that also? Yeah, connection threshold, connection distribution. The connected percent, though, where's that coming from? That should be there, but it's not. I'm gonna add it. I don't know why it's not there. Where did it go? I swear it was this.state, this.props. See, so I'm treating it like a prop when I should be treating it like a state. Because it's not a prop, it's a state. Now I'm getting confused between props and state now. My own internal state. Okay. This is super messy right here. Do I want this? I don't think I want this. I do want this as state because I want to pass it. No, I don't. I don't want this as state anymore. The only reason I have this... No, I do. I'm sorry. I do because I'm using it here, right? It has to be page state because I want to change it and I want the diagrams to update. Okay, so it has to be page state. So here, this should be connection threshold. That should be state, state, state. distribution center should also be state. I don't know where else, and it is state, percent. All right, now here also. But, so in this case, if my state updates, if somebody updates one of these function or one of these values through the UI, I need to run component did update again. I'm not sure if that's going to happen. Because that's what is going to, because these aren't props really. These aren't props anymore. I don't think this is ever going to run. So I'm going to create the SP the first time I see data. And then after that, I'm never gonna create it unless so I don't think this is ever gonna run. Pretty sure. Let's see if it at least will run without an error. Holy cow! Sorry, Stephen Long. Oh, you're giving a book recommendation. Self comes to mind. Okay, I gotta take the debugger out. Okay. Yay, okay. But now if I don't have a way to change, like if I change, this is for something else, but I think I can leave it for right now because I'm not trying to change anything. But if I wanted to change the connected percent through a UI, I don't think it would work. But at least our potential pools are consistent over, yeah, they're consistent at least. And that's what we wanted. We don't want to create the spatial pooler each time. So I'm gonna take this out for now and we'll deal with that when we need to deal with it. But for right now, we're only going to create the spatial pooler. This is the only time this is going to update is when there's new data. Or I guess when you call set state. Hey, David, are you still there? Because something's confusing me. When I call set state, I get component did update again. And the thing that bothers me is I've got previous props that I can compare to my props, but it's not props that I'm setting, it's state. Props is what I get in the constructor, right? State is what I set for myself. I'm a little confused about that. Mark says, allow an object to alter its behavior when its internal state changes. The object will appear to change its class, so property, but not really. All I'm trying to do is send as little amount of data as possible into these diagrams. For example, this one, all I'm sending it is potential pools and encoding. This one is just going to get permanences and encoding. And then all of the heavy lifting is done outside by the spatial pooler. So I think I'm close to this, but something feels weird about this this update. Just because I have to check just for data. The props, the only thing that I have in props is data. All this other stuff is state, as far as I can tell. Actually, let's put a debugger right. No, let's put a debugger right here. Debugger, and then when I get into set state, I want to see if I come back to this same debugger. All right.
It's going to be hard to tell because of the data is going to be updating a lot.
Yeah, every second. But when I go into set state here, this should work, and I have new encoding. Do I come back into this? by previous props, but this dot props is 7007. It's the same data, so now it's not a data update. So what's confusing me is,
Yeah, and it skipped it.
how can I tell? Like when I call set state, it doesn't make sense to me that that component did update call is called at all. It's just to give an opportunity to re-render because state changed, but previous props has nothing to do with state, right?
Previous props is just what the previous state was when either props or local state changes.
So the context of this function could be a prop change or a state change.
Right. So it looks like it worked as expected, where the data value change, you set state, it came back in, skipped it.
Yeah.
Because the value.
It does look like it worked as expected. So maybe everything's fine.
Is there an issue that it's showing up?
I was just confused about the difference between props and state there for a moment. I think I'm past it.
Yeah, when it comes to the component itself, the state of the component is made up of props that get passed in, state that you have locally, and any dispatcher props. But you don't have to worry about that now because that's like methods that
Okay.
update.
Okay. All right. Okay, so let's try and hook up the permanences one then. Let's try and get this one back to working. So we're going to have encoding again. We're going to pass into this, and instead of data, it'll be called permanences, and it'll be state.permanences. Now we have to go change all of that. Okay, so we're not going to be calculating our permanences ourselves. We're not going to be keeping track of our mini columns. We will have a selected mini column. I don't think I need to worry about this anymore. This is old. Maybe I had lifted this. Right? No. There's a calculation in here somewhere. Draw a histogram. Where was I doing the actual? I may have already pulled it out. Okay, well let's just look at the render. So when we look at this dot props, there's diagram width, input space size, diagram width, connection threshold. Let's split it here. How we are creating this. All we are going to get aside diagram width is encoding and permanences. This other stuff we don't want at all. What the heck? Okay, so like connection threshold we don't want, and we need to figure out how to make input space size. I need that. No, because we're going to have an encoding, so we don't have input space size. What am I using connection threshold for? For the fill? So these are already going to be colored, I think. No, oh no, they're not. Right, so I have a completely different data structure that I'm passing in here, I think. So when I render...
Yeah, because you...
So I just have to... I'm going to have to update to use... It'll probably be simpler. So this isn't going to be right. This one. This... So when I call data to these, I'm calling this dot mini column selected mini column. What I want to be calling is this dot props dot permanences selected mini column. Yeah, so that'll be the permanence values. selected mini column. Like this. So this is going to be an actual permanence value. So yeah, so this actually is going to work. Yeah, if D's above the connection threshold, it's connection color. That should work. This should work too. This actually, that might not. We'll see. We'll find out. Diagram with input space size. Okay, so this is, now we have to say encoding dot length. Where else do we have this dot props? Permanences, diagram with connection threshold. Okay, why do we need this? Oh yeah, we do want the connection threshold, so we can draw that line. But that's easy enough because we have that here. Over here. The connection threshold, boom, is part of our state. So we're going to send that in as well. So we'll send it connection threshold, just like that. And so now we can refer to it, and we're going to draw our line based on that. Okay, what else do we got? ID, we can have, that's okay, your diagram with, diagram with, diagram with. Diagram with input space size is encoding dot length. Diagram with, diagram with, diagram with, encoding dot length. Okay, let's see what broke. Let me take the debuggers out. I want spatial pool debuggers. It's gone. Okay. Can't read property length mini columns 52. That's typical. Oh man, I just tried to go to line 52 with the wrong command. Okay, so this is going to be permanences length. Anywhere else we're using mini columns? Yes, so this is going to be permanences at selected mini column, I think. Yeah, selected mini column. And actually in the other one, I do have selected mini column. And the one I just did, hold on. That's right. Permanences length. This is going to be at selected mini column. So it's the permanences at the selected mini column. Format document. Okay, all right, where else? Mini columns, permanences, mini columns, props, permanences. No, mini columns. There's another one. Permanences. I'm like failing at search. Okay. All right, let's see what happens. So we don't have permanences here at 52. Because we're... Oh, this is actually... I need to select the selected mini column. So this is kind of silly, but it's permanences this dot selected mini column. I think. Or not. Okay, let's see. Where are we here? This is in permanences 52. Right here. What do we got going on right here? Permanences is undefined. Oh, I'm saying this dot permanences when I should have been saying this dot props dot permanences. I think. I have this all over the place. Yeah. So I need to change all of these this dot permanences to this dot props dot permanences, I think. Okay. So let's do this dot permanences. 3. This dot props permanences. Okay, do all of those. All right, let's see if that helped. Certainly didn't, well, at least not in this case because I don't have any permanences yet. So I'm trying to render mini columns, and I haven't gotten any data. Can't render mini columns.
You gotta add that if undefined
Yeah.
or if data.
Yeah. Okay, so what am I? Let me see here. What happened? I keep. Did they come again? I don't think this is. That was just an ambulance.
Man, you live in a dangerous city.
I am right downtown, so you get all of the activity. Okay. So the same. I did something similar in the other one, didn't I? Under update. Yeah, basically that. Right. If this is really an update, but it's if dot props dot permanences, and I want to do it. I hope that's all it takes. Not quite. Let's see here. Connection threshold's not defined. That is on 152. SV, oh, that's in permanences 152. Connection threshold. Oh, right, because I removed it. It should be this dot props dot, I believe. Oh, that's just a.
Is this gonna be defined in Tona?
Yeah, I'm gonna just set it out here. Whoa. Wow, that's interesting.
Well, that looks cool.
That's not what I expected. Potential pools is still working, so we didn't break that, but cool. That's interesting, isn't it? So the input isn't right at all. So it's probably something with the input.
Oh, it's because of the data structure that you're passing it, like with color information and everything.
Yeah. Okay.
Because whether you tell it's connected or not, based off connection threshold, right?
Right.
But you only get the encoding.
So let's rethink this a little bit. Let's go back to spatial pooler where we're doing that logic. So here's where essentially I'm calling get potential pools for both. How about that? If that fixes it, that'd be amazing. Woo! Look at that. Okay, that's good. There's a couple things that are a little bit off, I think. Okay, so this doesn't work. This one works. So I don't quite have it set up exactly right, but I think we're close. Okay, so one of those things get through. This is the connection threshold, that through, but I'm not passing these through at all. That's the issue. Because Right. When those, I'm not checking to see if those update and recreating the spatial pooler. So what has to happen is when I move this, it recreates the spatial pooler because we've changed its connection distribution, parameter. So it has to reinitialize everything. So I think that we just have to have that check. Because we're only checking right now if there's no SP, we'll create a new one. But otherwise, we need to see if, again, any of these things have changed. That's the check that I did have that wasn't working the way I expected, and so I took it out. This is only a data change. So that was in my else statement down here. And if any of the other... So that would include, like, if this changes, this will run. And if any of the UI changes any of these, this will run too. So if I just add this here, I'm not sure what'll happen. If I just create a new spatial pooler on that, and it gets...
You're gonna want that if it's not defined yet, too, right?
Probably.
Oh wait, so anytime you change like the connection threshold or any of that stuff, it's supposed to recreate the pooler?
Yeah.
Well then yeah, leave it like that. You don't need that.
Well, let's see if that works.
But
Yeah, I still have to have the check.
so but where are you passing the spatial pooler, the props info that's changing? Because like you're passing it state.
Well, that's not updated at this point. I thought that would be updated.
What updates that?
The UI component.
Right, but doesn't that update it via props?
Via state, like this, right? So it's going to call set state, and then I should be able to get it here. This will be the new state. Or am I missing something?
Oh, this is the outer component. Oh, okay, so this is what component is it?
This is the page. This is a spatial pooling
Okay,
page.
okay, yeah, I got you.
We'll see. Okay, so if I change this, it doesn't do anything. So I want, this should change, this changes because because the component's listing to that directly. But these, only the page is listening to it, not the diagram. If the page is listening, let's see if I'm getting to this point when I do this. That would be in spatial pooling. I'm expecting a new SP to be created right here when I do this. That doesn't happen. Where does it get to? All right, let's do this. No, I don't want to do it yet. Oh, I keep forgetting because data keeps getting updated. Okay, so is this for if there is no SP, but there's always an SP. So this isn't, I don't want this. I want to recreate this every time. Even if there's not, if there is or isn't an SP, we're overriding it essentially. Maybe that's the problem. Coding that length. That's okay, that's gonna be this dot. Oh. Yeah, this dot encoding that length.
Yeah.
This dot.
Do you? Okay. With the don't you need the
state? This dot state. Encoding. Because that's part of my state.
Are those ifs correct? It looks like that. I gotcha. I thought you called this encoding at the top of that message. Though. This encode.
This is weird. Or is it? can't tell. I can't tell if this is weird. Maybe this is...
Is that because of like shouldn't this be outside, or shouldn't this be?
I'm sorry, I'm distracted. I'm trying to figure out some other things. This is really close to being right. Okay, so all the updates are working fine. The data update's also working fine. But what I'm not seeing is the encoding array, like the encoding under it. And it may be just because I'm overwriting it.
So this line is encoding it when the value changes, and then you're just using the state value.
Uh-huh. Yeah, so what I'm banking on is this only gets run when the HOC has injected a new data point.
Mm-hmm.
And then this runs to do the calculation. And if this is only going to run if the user basically changes something. It's not a data update essentially, or actually it's going to run when this calls.
It's going to run every time. Yeah. Mm-hmm.
So what I really want here is this is where I wanted that long stupid if statement that says if it's a connection threshold or if it's one of these things, then update the SP. Otherwise, don't, because the SP should not be recreated every time we add potential pools of permanences. So this is where I'm going to put that ugly if statement, and this is only going to be if previous props dot connection threshold has been changed. I can say this dot state dot connection threshold. Or the distribution, or the connected percent, or the distribution center, because those are all the things that would force the SP to be recreated. Honestly, the connection threshold is not. If it's just the connection, well, I don't want to deal with that now. Like we could. There are certain things that you could just set on the SP, and it doesn't have to reinitialize it because it creates the connection sort of on the fly. It checks the permanences on the fly. So if you change the connection threshold, you shouldn't have to reinitialize. But for right now, I'll leave it. So basically, we need an OR for these four things here. Hey, Strawberry Jesus, how's preaching? Okay, connection threshold, connection distribution, connected percent, distribution center. Distribution center. So if any of these things have changed, we're going to recreate the spatial pooler because it's got to reinitialize all of its permanences. And like I said, that's not exactly right, but it's close. So there's something wrong here. These connections shouldn't be. Well, I don't know. I can't tell because I can't tell what the input is. I need to see the input. So let's look at this and see why the input's hidden. There should be a class for permanences and then the input space. Okay, so we're just not drawing the input space. So there's something wrong in our function and the permanences that is rendering not the permanences, not the mini columns, not the connections. Am I not even drawing the input space? Did I take it out? Excuse me. I don't even have a block that's drawing input space here. Did I forget to do that last time? Over here, in my potential pools, I'm drawing the input space sort of, or the connections. Permanences, connections. Yeah, I'm not. Okay, so I think I can just steal this from potential pools. Do you have any idea how terrible pointer-based code explodes if you are sort of right? Ha 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 ha. So render input space. So here we go. I want to look and make sure this is the same sort of coding paradigm here. I have an input space. Apparently I forgot to do this in the last one. It's going to be really, really similar to this function, render input space. And if I don't have a render input space function, which I don't seem to, then I should probably create one. That's amazing. I completely forgot, apparently, to do this last time. Okay, so let's create a render input space function. Put it right above draw histogram. And this is going to be... well, where did I do it in potential pools? Right after Minicolumn. So we'll do it right after Minicolumns, just like the other one. Render the input space, render the permanences, connections, and the histogram. So, let's see. That's correct. Coding, that's correct. That should be correct. Now it's the data. That should be, that's actually going to be, is that going to be part of my state? I forgot. No, this is right. That'll be a prop. That might just work. That might work. Yeah. Okay, but okay, so we're getting closer, but this is wrong. I've got obviously some spacing that's totally off. Like up here, oh yeah, so these mini columns are wrong. Those aren't the same dimensions as these, obviously. So there's something totally wrong with the mini columns. Let's make sure I'm setting the right thing in. I'm setting in permanences, potential pools. So how is it calculating the mini columns? It's probably just connections, permanences, mini columns. So we're probably just grabbing the wrong type of data or something. Right, this is it. So when I'm doing the mini columns, I'm not selecting a column. I'm using all the permanences. That should be better. Those might break. Okay, so now I got to do something differently. Again, this is wrong. I remember coming in and doing this and not knowing at the time what I was doing. Okay, so that's better. So now we've also got a length problem with the output here, obviously. So the input space looks right. Yeah, so that looks right. But the potential pool is totally wrong. Oh, I know why. Because we're only showing the permanences and we're not going and getting, we need the potential pools as well as the permanences so that we can identify the input index. So here, I'm going to send it both the potential pools and permanences, because this needs both. So that's going to be part of its state. And so this is actually not too hard to do. When we go do render perms, where do we get this? So here's the perms for the mini column. In here, so when we're deciding X and Y, we can't use X anymore. Here's what we're gonna do. We're gonna get the pools here, const pools equals this dot props dot potential pools. Okay. We have a selected mini column, or do we? This is permanent, so we do. We should have a selected mini column at this point. So we're going to only get the potential pools for the selected mini column, and that's our pools. Now we use that pool to decide the I index. So we're going to go to the pools to find the I index here. and we're going to go to the pools to find the I index here. That's the input index. That should change this display properly. Now we have to do the same thing with the connections. Okay, because we're doing, basically we have the same error happening here. So I'm going to grab the pools. This is just a repercussion of the structure. The spatial pooler is returning. The pools structure has sort of the links to the input space. So this should work now. This should look better. Oops, close. Pools. So we have the permanences, but they're indexed so that they match the pool index. The pool and the pool map, or the pool array, has got the identify links to the input space. So we're just basically going for the permanences to get the input index we need to link to, and that's how we're calculating where it's going to be. So this is great. This is what I want. And over time, oh shit, that doesn't work. That's not working. The potential pools are being recreated every time. And it's happening on here too. Okay, we're back in the place where the SP is being recreated. It's not what I wanted. Why is it being recreated just on data change? We're so close. We're so close. So here. Okay, it's not there. Here. All right. So we've just had a property change, which was, it should have been a data change. So let's see, the current data value is negative 1.22. The previous data values, so this was not a data change, but so what changed then? Something's wrong here. Oh, previous props, connection threshold, previous props. Okay, so this part's not working, where we're checking to see if any, we're checking the previous prop. So when I call set state, and then component did update changes, how do the previous props is not giving me a link back to my previous state to check. So I don't know how to resolve that.
Wait, I think if I remember correctly, there might be the second parameter may be previous state.
Oh, okay. Let me. That would be useful. Let's see what our arguments are. Just got one argument.
Yeah, the second one is previous state.
Okay, great. I can use that. I can work with that. Okay, back to spatial pooling, where we're deciding whether to recreate. So we've got previous props, previous state, and we just, hopefully, we can just change this to previous state and only recreate that spatial pooler when necessary. Cross your fingers. There we go. That's better, right? That's better. That's better. So our connections stay the same just because the input is changing. We're not learning anything at all yet. We're not learning anything. If I change this, it shouldn't change, but it does. Yeah, I remember that. So I said we shouldn't have to recreate this spatial pooler on connection threshold, but we decided to anyway. So if any of these changes, we'll recreate the spatial pooler. Let's put this at like 4. All right, this is in a good place. This is in a good place to commit, I think, at the moment. Because, yeah, I think this is a good place to commit. This is cool, all right. And then we're gonna go do Minicolumn competition. So we're gonna create a new diagram. We haven't even gotten to the overlaps yet. I'm gonna take a break. I'm gonna commit this, push to the branch. Dean and I will go have Chinese food or something. And then we'll come back and do the Minicolumn competition. Diagram. Okay, let's see. let's see. Let's quick review of what we've changed here. This is white space changes for the most part. Right. Added render input space, which I was never even doing before, apparently. And only if permanences change, yeah, update if there's permanences. This is just remapping of data. Remapping data. White space change. Remapping data. And then render input space, which we weren't even doing before. Which I think that's all fine. It's all pretty standard. That's just a white space change. Okay. What else? One more. This is a spatial pooling. I just added some comments. Hopefully you guys can see this a little better. We moved a bunch of state around. You know, that's one thing. We're doing all of our SB computation now on data update. I want to clean this up, and I will, but I'm not going to clean it up right now. I'll put a fix me in here. Up SP initialization. And then our permanences, we're sending in thresholds, encodings, potential pool. Okay, everything. All right, this looks good to me. SP in place for potential pools and permanence diagrams. All right. Thanks, David, for your help on that. Git push origin using SP. And I'm going to go ahead and probably just merge this. Yeah, I might as well just merge this. I like to group things in pull requests even if I'm not like directly working with other people, because when somebody comes back and looks at it, they can say, oh, this, yeah, they can see the chunk of work that you've done and at least maybe see what you were thinking. So this adds a bunch of stuff. This adds the initial permanences diagram, permanence histogram, initial perm basics, and I'm gonna merge it without CI. It's not really doing anything. I think it's trying to deploy, but okay. So we haven't really changed any functionality as far as I can tell, except we added this input underlay, sort of, because you can see the input. So now we're going to move on to the Minicolumn competition, which you can see here is the diagram for that. So let's go grab some lunch, Dean. Let's go get lunch. All right, you guys, we're going to take a break. We're going to be back. We're going to do the Minicolumn competition diagram, which I think will be not as hard, not so hard. I mean, the hard part's done, right? And then it's just like doing the D3 part next. And that's fun. Yeah, we can go with you.
I also need to go at that.
Right. Where were we? Where were we? Okay. We're building HTML systems. We're doing spatial pooling, and I just merged a bunch of stuff. I should be able to go back to master, pull everything, and get everything I got changed. And we should now be totally up to date. Totally up to date. Close all. All right. Okay, still live sharing, I think. Yep. And I should mention, how do I get that link again? Copy link. So I'm still live sharing. Here's the link to the live share. If anybody is new, for whatever reason came while I was out to lunch, here's what I'm doing: live coding, building HTML systems. And now we're going to create a new diagram. Let's create what I want, or what I think I want first. Again, this is in spatial pooling. Down here, we're going to create a new diagram. Under permanences, just copy this. I don't want that part. And this won't be called permanences. I'm just going to call it Minicolumn competition. We could call it inhibition. That's what it's called in a lot of the HTML literature, is inhibition. I'm going to call it Minicolumn competition. Column competition. I don't know, I just like that. It was really useful fortune knowing that it would not be held to it. Yeah, you're right. So I did that once at a Chinese place as a joke with my wife and kids years ago. They had all opened their fortune and they were waiting on me to open my fortune, and instead I just threw it in my mouth and ate it. and like I've never been forgiven for that since. So I try not to eat my fortunes. Diagram width is fine. Connection threshold encoding. Okay, so let me think back to what we were. So what do I need? I'll definitely need the encoding. To do this competition, we're going to need permanences. Well, actually, the SP is going to do the competition. We're going to get back overlaps. So what we need is encoding and overlaps. So instead of this, overlaps. This state overlaps. So we're going to add another state called overlaps, and that's going to be a part, excuse me, of our state calculated upon automatic data change. Overlaps, undefined. Oh, it's another ambulance. It's not very exciting. Trying to get through traffic. That's a hard one. Overlaps, undefined. And we are going to define them here when we set our state. Overlaps, this.sp.compute. Well, that's going to find the winners. So maybe that's what I want. Maybe I want both. That's actually winner columns. Let's go back and look at our spatial pooler. We've got a compete function where we send it input and it will give us back winners. And then, but we're not really storing the overlap. So let's first work with what we got and just use the winners, and we'll just display the winners. We can display perhaps the permanences, because this looks like we've got, what did I write here? Using the, so first of all, I've got the encoding. And then for each input, the state of the mini columns. And this is a heat map of overlap with the current input. So I need to get to do this heat map the way I want. It's not going to be permanences. It's going to be the overlap count. So I don't even have that exposed here. I create overlaps in the spatial pooler, and then I just return the winners. So all I have is the winners overlap scores. I don't have the rest of them. So what I should do is essentially, I mean, the easy way to do this would be to just sort of expose this. I could call calculate overlap every time someone selects an index, but I don't really want to do that. I should just do that all at once. Maybe I should do it once per, because otherwise I'll be doing it, you know, hundreds of times per iteration, per data point, you know. Maybe that's not what I want. Maybe I should use calculate overlap and somehow have the selected mini column hoisted up. That way I only have to compute, you know, just for a one selected mini column. So that's one option. But the easiest thing that I could do would be to just say, you know, after I've done this, say this dot overlaps equals overlaps. And they'll be sorted, which isn't what I want. But it doesn't matter. It doesn't matter if they're sorted, because it doesn't matter. So if I do that, honestly, I could do this in place. So if I go into simple HTML, this is my local version of the code, but it'll at least prove to myself. So I could just do this dot overlaps equals overlap sort. And I think now this will at least prove to me that it'll work. If now when we do the computations, we have to run compute. Okay, so we will have to run compute before set state. Compute takes an input. The input is the encoding. All right, so we're going to compute on the encoding, and then we'll say this dot sp dot overlaps. All right, let's see if that works. Does that make sense? Is anybody following me? Maybe talking to myself here. That might work. But all right, so let's push through, and we're going to have to create a diagram and test it, basically. So I'm going to create one called Minicolumn competition, which doesn't exist yet. Trying to follow, still here? Okay, good. So let's go to, whoa. I don't want all this stuff. How'd that get open? New file, Minicolumn competition JSX. I will just take the permanences and reuse it. I will definitely use D3, use the prop types. Not sure about any of this stuff. Probably diagram padding. Connection color? Am I doing a connection color? No, there's no connections here, so we won't have. We'll see. We'll see what we need, what we don't. We're definitely going to use the red to green thing. This is going to be called not that. This is going to be called Minicolumn competition. Okay, this is also Minicolumn competition. Minicolumn competition. Minicolumn clout. Really? How long has that been there? Let me go fix that in permanences. Minicolumn clout. Am I actually using that? I don't know. Minicolumn clout. Love it. Okay. Yeah, save it. Okay, so now in the class, we want the refs. There is going to be a selected minicolumn, so we'll keep that. This is probably still pretty much the same. Update. So we're going to render. I keep going back to the iPad. We're going to render the the mini columns is the bottom one. The input space is the top one. The permanences is on top of the bottom one. The connections is on top of the top one. Let me. Yeah, so there will be connections in the end. This is like the big. Why does it keep doing that? I'm sorry. I don't understand why it's doing that. It's like jumping back and forth. So input space, permanences, connections. Permanences is not getting rendered. Permanences is not getting rendered, but overlap. So instead of permanences, we're going to render overlaps. Render overlaps. So that will be the gradient, you know, red to green thing. The connections is going to be the blue on top of the input space. The histogram, it does not exist. Okay, so this is what we're left with. And this isn't permanences. This will be overlaps. Overlaps. If we get overlaps, that's the one thing we're worried about here. So this is spatial pooler. So again, we're going to send it in. We're going to need a connection threshold. No, we're not going to need a connection threshold. We're going to need the encoding. We're going to need the overlaps. And I think that's it. I think that's it. Okay, so see you later, David. I'll be here. I'll be here another hour or two. I want to try and get this done. I think we can get the basic visualization of this done pretty quickly, and then next time we'll start adding knobs and things to change the state of the diagram. Okay, so we have a render mini columns. Let's go bit by bit here. The input space is going to be first, so let's make that first. Okay. Let's turn you off, turn you off, turn you off. Okay, so we'll do input space. That doesn't work. We'll do input space first. Somebody likes the motorcycle. Okay, diagram width is good. Input space, that's good. Let's also check. Let's check our markup, our SVG again. Okay, so we're gonna have, looking back at the screen, we're gonna have two things. We're gonna have one input space in one area, and then the mini columns and a bunch of overlays on both of them. So we're gonna have space. We're gonna have an input space. We're not gonna have any permanences. We are gonna have connections, though. I think I am going to show a potential pool and connections. Now, in the second space, we're not going to have a histogram. Okay, I'm going to actually change some of this. So let's not do the mouse move thing for now. We're going to have one group called mini columns, one group called input space. That's probably the cleanest way to name this. And inside those groups, excuse me, potential pool and connections is going to be in the input space, and we're going to transpose just the group sort of to move it where we want it to be. And in the mini columns, we're not going to have a histogram. In the mini columns, we are going to show several things. We're going to show overlaps. Okay. And we're going to show winners. Okay. Winners. Winners of the competition. So the overlaps are going to be gradient colors, and the winners are going to be some type of box. Maybe they'll be the same. They could be exactly the same. Now, one of them I was like, I might make them a little different. We'll see. We could show the winners at the same time, or we could show them differently. I don't know. We'll see how it comes. We'll see how it turns out. But I know I'll have two groups, one for the input space and one for the mini columns, and that matches up with the input space on top and the mini columns on the bottom. Okay, so there's plan A. Plan A, that's what we're gonna do. So focusing on the input space, first of all, let's not even, well, really, we gotta do potential pools and connections. So I've already got one for connections. But I don't have one for potential pools. But I do in another diagram. So let's go to potential pools because I'm pretty sure there's, I think it's, oh, here it is, render potential pools. So we should be able to reuse most of this because I want the potential pools and I want the input space and I want the connections. So I'm gonna actually do another one. I'm gonna call one input so that the input space will be all of the things, all the overlays sort of on top of each other so that I can move it around. The first one will be the input, the gray boxes. The second one will be the potential pool. The third one will be the circles for the connection. So let's work on that first. I'm even gonna just comment this out for now. I don't know, there's no reason to comment it out. Okay, so first input space, what did I say? Input space, which is the input, potential pool, and connections. So when we say render input space, I am going to abstract this even more. Render input space, I'm gonna call render input, not space, just render input. And we'll call this render input. And the other thing was render potential pools, this dot render connections. All right, so those are the three things that we're going to render in that area. Input, potential pool, and connections. Let's take these off. We're never gonna do permanences. This is not a permanence diagram. The mini columns we'll get to in a moment. The connections we'll get to in a moment. So what else? Histogram is right out. We're not doing it. Mouse move at the moment, we're not. We will eventually, but for now, let's comment that out. Okay, so what do we got left? All we have is render input space. And that's gonna be render input, and then put pools and connections, which we haven't built yet. So let's first simply render the input and see how that works. This isn't gonna, I don't expect this to work right away, by the way. It's too many things at once. I don't think I have imported this, so let's import this. Potential pools permanences. So something like this, except we're gonna call this, where was it? Minicolumn competition. Minicolumn competition. All right, so we broke at spatial pooling component did update, so the spatial pooling 11 because compute is not a function, because it's not compute, it's compete. I was in NewPick spatial pooler, it's compute. I haven't even gotten to, I'm not calling it compute because we're not really computing, we're just running the competition. We're not, the compute is sort of a bigger operation. It's like, it includes learning and boosting and all that jazz. So right now we're just gonna say compete. Hey, look at that. All right, so something, so we got something. So there's our competition, but nothing's happening. Let's see, what do we got going on in here? Expect. Is anything happening in here? We have an input space. We have some input. Oh, I know why. Right away, I know why. Back to the competition. It's because this should just be input, not input space. And really what I should do here is right here is where I would transpose. So I could say G dot transform, I think, and then I could say transpose, you know, 200x 0y, something like that. And I think that will move it to the right before it renders something. Still something wrong here. Okay. Where's my stuff? Okay, well I have input, but it's not doing anything to it. And it's not transposing my input space. What's going on here? I expected, oh, right. This is input, excuse me, space. And I put transpose. Should be transpose. Now here, this should be now input. Okay. Let's see if that fixed my little issue here. Not quite. Hold on. All right, let's go to the source. What are we missing? Minicolumn competition. All right, I'm gonna have to put a debugger in. Thank goodness for debuggers. Oh, I have an error. I think it just needs to refresh. So I'm not even getting to this point. This is not running because I'm calling render input space. I want to call render input, which will call, oh, no, that's right. I'm calling render input space, which is then calling this, which is called render input. Sorry. It's because there's no overlaps, most likely, right? Yeah. Because I'm not sending it any overlaps. Because overlaps are undefined. And I must not be, here's where overlap should be set. Let's debug right here. And we'll see if we're actually getting any overlaps. Can we? No, SP underscore overlaps is undefined. So when we call compete, that's where I want to stop, because what's going on there? Maybe I should just bite the bullet and go to the spatial pooler in simple HTML and fix it the way it should work. So I'm going to call compete with this encoding, and I expect... Oh, so it's not, it is not respecting, I went and changed, okay, so let's go change this right here. This isn't where we want to do it. This is a little bit of a hack, I know, okay, but it's, it at least makes the overlap scores available. And here's what I'll do. I'll create a function called getOverlaps that just returns this dot overlap. All right, so if they're available, we can get them that way. So, but of course now I need to rev my version. Bear with me here. Rev my version. Okay. Get add package src. Get commit. Release 0.2.3. Expose overlaps. Get tag a 0.2.3. 0.2.3. Expose overlaps. Get push upstream 0.2.3. This is all just like programming minutia, software engineering crud you have to do. Get push upstream master and npm publish. Publish. So we should get a new version of HTML, simple HTML. Now I of course have to go back to my package.json and update to the latest. Okay. Back over here, npm update, or I have to kill this and restart it probably. All right, updated one package. Let's run it again. Let's see if we get our overlaps. Oh, actually, I'm gonna have to go change it because I was calling underscore overlaps when I really want to call get overlaps. Hopefully, this will work. I really want this debugger. Okay, well, we'll find out, won't we? Get overlaps is indeed a function. That's good. Repeat. I got a failure here. Hold on. Oh, expected transform function. That's something different. Okay, so I'm gonna take the debugger out because I think we're past it, and then let's figure out what these other issues are. So I transposed attribute transform expected transform function. It worked, so I don't know what's anyway. I don't need to do that, so I won't. Excuse me. We'll just leave it where it is. I don't need to do that. So this should be fine. Let's just put it back where it was. Why did it do that? Put it back where it was. That's odd. Why would it do that? It shouldn't be 200 pixels over anymore because I just removed the transposition. What? I swear I just transform translate 250. What did I do? Oh, I think I put this in the markup. I think it's left over. No, it's not. 250. What am I adding? There's not 250 anywhere. How is that transposition occurring? Transpose nothing. I don't get it. Here. Transpose nothing. I'm a little flabbergasted about how this transposition is happening. It's on the input, not the input space. It's a transform, translate. That's what I want. Okay, translate, transform. Something is transforming, and I thought I removed all of it. Oh, I programmatically had this. Okay. Ignore. I don't need to do that anymore. Okay. So this should be back to the left now. That's our input space. Remember what we're shooting for. Shooting for this. So that's the top left. This is the first simple version of it. Okay. So we got that bit. Now we want to add the next one, and let's put it to the right. Oh well. What were the other things? We were going to render several things on top of this, weren't we? We were going to render the potential pools next. Because this looks right. That looks right. So let's render the potential pools. Does that function exist? Nope. Okay, so we'll go to the potential pools. We'll grab this function. Put it under our input. And then we'll update it so that it works. These are other ones. Okay, so diagram width, diagram padding, that's fine. Potential pool might have an S. Nope. Okay. It doesn't have an S. Props encoding, that should be good. That should be good. Props diagram. Okay, hold on a sec. I'm gonna take this call. Give me a minute. right, just family planning. Family planning. Okay. Excuse me. Bye, Mark Brown. If I missed you, have a nice sleep. And Jordan, I'm on Jordan. Okay, where were we? Potential pools. We are translating this. No, we're not going to translate this either. This is going to be right on top of the input. Let's see what happens. Let's see if it just works. It's not going to just work, is it? No. Okay, this is wrong. Right. That's wrong, obviously. So we're not getting potential pools, but I apparently need it. This diagram is going to take potential pools just like the other, because we want to render them over the encoding. So we can do that. PP color. Sorry. I'm such a kid. Oh, PP color. Alright, I'm gonna take this PP color and put it here. Let's see, what other colors do we have? Probably gonna, okay. There we go. Okay, so we're getting there. Next is, alright, want to do connections. So I hesitate. I was maybe going to do this just on mouse interaction, but we could just do it all the time. What do I want to do? Hey, that's weird. Something happened to my... So I'm like... Where's my, one of my mobile cams is like disappeared. It's totally gone. It used to be right up there, now it's gone. Oh well. Whatever. Oh, it's my screen. Okay. There we go. I'm just confusing myself. Alright. I still don't know why it's jumping all over the place, but let's go ahead and do the connections. One of it is connected synapse with no overlap with input. So I'm trying to do it differently depending on whether there's overlap or not. Whether we fill it. I think we could just do this, right? We could just do it. All we need is a selected Minicolumn to be able to do this, so it doesn't have to be on mouse interaction. Well, it does, because that's what identifies a selected Minicolumn, right? But if we just start with one selected Minicolumn, and then from that point on, the mouse interaction changes to selected Minicolumn. All right, so let's assume there's a selected Minicolumn, and we will draw the connections. But now I've got half a mind to go ahead and draw the other structure first, just to get something to select the Minicolumn. I don't know. Dark mode for my console? I am using dark mode, aren't I? I think I am. I've got dark mode on my Mac and dark mode for VS Code. Anything else? Trying to decide. Oh, my browser. Yeah. I'm not that into aesthetics at the moment. I'm gonna skip the connections right now. We're gonna skip the connections, meaning I'm gonna skip this bit. I'm gonna skip the I'm gonna skip this part, right? The blue connections, like these things, and we're gonna go straight to this bit, and we'll try and do the selected Minicolumn, and then we'll display the right potential pool. So let's do that. Let's do that. Get the mouse over working first, and then we'll display the connections and the potential pools based on the mouse over, based on the selected column, which I've already got set at 0. And we've done this in a bunch of the other diagrams as well. In fact, We've done it on permanences and potential pools. I think it'll be easiest to grab from potential pools. And all it was down in our SVG, we got this handle mouse move. So we just, on mouse move, we do this. On the, it would be on the mini columns. So we go to mini column competition. When someone hovers over the mini columns right here, we're gonna handle mouse move, and I've already got it right here. And all we're doing, and this should still work, I think. Get attribute data index. I'm not sure if that's gonna work. We might have to set that up. Data index. Oh yeah, so as long as when I render the mini columns, I add this data index, this will work. So that's the plan. That's what I'm planning. That's what I'm doing. That's what I'm gonna do. Okay. Okay, so let's render mini columns. I'm just gonna steal this because it's probably exactly what I need. Mini column competition. I've already got the function right here. So let's uncomment it. I don't need to, and it already has a data index. So the mouse over thing should work. All right, so render input space, render mini columns. Remember, we're not doing the connections yet. We'll do that later. So input, potential pools. We don't have connections. Let's move this. I want to try. I like to keep things in order. At least try to. Okay, let's move the connections up above the mini column since it's sort of part of the first diagram input. So for our mini columns, well, first of all, let's just look at it and see what broke. Props.permanences.length. Okay, so I don't want permanences. So whereas the old one was looking at the permanences, that's not what we're going to be looking at. We're going to be looking at the overlaps. Right, and that's the amount of mini columns there are. So anywhere else where there's permanences, it's going to be overlaps. Okay, and I still don't think this is quite going to work, but we're going to be close. Selected color is not defined, so let me just steal that from here. I'll just do red. Connection color is eventually, oh, that's not, I'm not going to take that yet, but I will take selected color. Our colors are kind of a mess right now, but we will clean up eventually at this point. Oh my goodness. Oh yeah, so I have to transpose this, although it does seem to be working. Let's transpose this, move it over. So in render mini columns, so I'm selecting mini columns. So what I really want to be doing here, let's call this SP. Okay, and let's call this mini columns. All right. So now now I'm going to have a render input space and a render SP for not why did it do that? Render S. Let's call it spatial. Let's call it competition. Render competition. All right. So I've got render input space, which calls render input, render potential pools, and eventually render connections. And then we're going to have render competition, which will then call render mini columns, overlaps, and connections. Not connections, but overlaps. Render mini columns, render overlaps. Whatever it needs to. Whatever it needs to. So we're going to create this right here. Render competition. And actually, that's what we're going to transpose, just like we did in this other one. So I removed the transposition, but I'm going to steal it back. Where did it go? Render input space. Here it is. Split screen. Okay, so we're going to move the whole mini column competition. So first I need to get the G. Let's say const G equals, let me go back and steal this dot root select, right? This root select, and we're gonna call this competition and rename it down in here as well. So it's called competition. And it has, let's look again at the thing. It's gonna have, first of all, I think it can just render the whole thing at once. It's gonna have all the overlap colors, and it's gonna have the winner columns, and they can be done in the same path. So let's do that. Let's just call it render mini columns. And we'll do the overlaps and the winners at the same time. We'll like highlight the winners just with a border around the box or something. So we'll have competition and mini columns, and we can, I don't know about, anyway. So the competition one is the one I'm going to transpose, move to the right half, and then we'll call render mini columns and assume that does everything we want, right? And that's going to render the overlaps and render the winner cells. Okay. So we're going to use the overlaps, and we're going to decide where things are. Let's just see what happens first of all before we get excited and start doing a bunch of stuff. Okay, so this selection is working. That's excellent. Potential pools are stable. Okay, let's just dig in here. I just want to see what everything looks like. Okay, so the Rex. So I want to update this. I want to show a heat map based on overlap. Okay, so render mini columns. So the fill, here's the fill bit. So this isn't what I want. It's not just selected color or whatever. I do want the selection maybe, I don't know how I'm gonna indicate a selection. It's not gonna be by color though. So I'm just gonna get rid of this. We're gonna write our own logic here to do the fill. For now, I can just return gray just to make sure that it's working. Okay. But what we really want is, we want RGB, we want a hex color that's dependent on the overlap. The overlap's gonna be anywhere from 0 to, I don't know. Let's find out what the max overlap is. Max overlap is, so we got this dot props dot overlaps. I'm gonna have to map this. I'm gonna have to map it so that I can say, so I can return O dot overlap, because overlaps dot length. Yeah, because I think the overlaps contain an index and they contain an overlaps, and the overlaps is an array of all the indices that it overlaps. So what this will do is give me all of the links, and then I can say math.max, and hopefully this is the maximum overlap. So now I should do the same thing for the minimum overlap. So just do math.min. And I want to see this. I want to see this work. It's broken. Overlaps cannot read properly. So overlaps is not defined. Okay. Props.overlaps. How am I setting this? Overlaps. State. It could be that they are not defined yet. It might be that they're not defined yet, because when we set state here. So it may be that they're not defined, and I just want to do a check. I just need to add one check. And I don't want to render the mini columns if there's no overlaps, right? So if this dot props dot overlaps, then I'll render the mini columns. Otherwise, I'll wait for the data to update. All right, next, 180 can't be properly length of undefined. Are we still at this? Overlaps is still undefined? This doesn't make sense. I thought I'd just like put something in place to prevent that. Apparently no. This dot props dot overlaps is not undefined. And it does have a length, so maybe it just needed a moment. No. Oh, that's a different one. Oh, I'm calling o.overlaps here. Okay, hold on. Oh, this is in the map function. This is, okay, let me just, all I need to do here is inspect this a little and see what I'm doing wrong. So the overlaps is an array, and each one has an index and an overlap. Some of them are 0. I didn't expect them to be 0. So it's not overlaps, it's overlap. Okay, this overlaps, has an overlap. But I didn't expect them to be 0, so that was sort of, there should, most of them should be 0. Let's see what the min and the max are. No, we got another failure. Okay, math.ming is not defined. There's no ming, and there's no ming function. Okay, can we see the overlaps max, please? Max is NaN, min is NaN. Okay, I'm obviously doing something awful. So for each one of these, there's an index and an overlap. And the overlaps are all empty, so there's something wrong. But this length should be 0 then. Okay, so I'm gonna expand this and step into it because I can't figure it out, and I'd rather know exactly what's going on here. So let's take this debugger out and put it right here. Is it because I'm not saying return? I shouldn't have to return if I structure the inline function that way. Okay, O dot overlap dot length is 0. So the max should be 0, right? This max overlap should not be not a number, it should be 0. So that's what I'm not getting here. It may be that I just am not returning properly. I just want to see the max overlap. Where we go? It's still not a number. Math max. Props overlaps. Map. Turn O. Very strange. Something stupid. It's something stupid I'm doing. It always is. It's always something silly that I'm not thinking about. So I'm mapping, and then let's stop. This right here should return an array of integers. Oh, I know. This is a problem with math. You need to put dot. This is stupid. I don't know why they did this and why JavaScript works like this, but you can't send it an array of numbers and it won't give you the max. It'll say not a number because it expects a list of not a list, just arguments of numbers, which doesn't make sense to me. But okay, so now I think this will work. At least I should get a min and a max, although I'm still concerned.
You can pass an array, you just have to do it with like an apply.
Yeah.
Or a call.
I wish I didn't have to. But this works fine. This works for me. But why are the overlaps all 0 is what I want to know. My props. Okay, something weird. Oh my, I ran through the whole playlist, the whole Mellow Beats playlist. I'm gonna play something else. Chill House. All right. We're close here. There's something silly's going on. My props overlaps are not what I expect them to be. So let me go back up in the spatial pooler. Right here, I'm saying get overlaps. After I've so let's stop. Let's debug right here. Okay, so here we go. We're right before we are going to run the competition. We run the competition. Now, we should have SP underscore overlaps. And these are all 0. So what's going on? Is my input empty or something? My input encoding. Oh, right. It's full of colors. It's full of colors. Okay, that's not what I wanted. I have to. I can't send in a bunch of strings. I have to send 1s and 0s. Right. So this is the encoding that's like combined, the combined encoding. FB, I think.
So do you send it just like a bit array, or just an array of indexes of the on bit?
I can't remember. I can't remember what I did. So in simple HTML, I'm trying to get my code up. Okay, so in simple HTML, I'm sending it when I call not in code compete. The input is a 1 or 0. So it's not an indexed array. It's a big array of 1s and 0s. So that's what I was expecting here when I run this, and I am sending it into something totally different. So in the spatial pooler, this.encode is not really doing what I want. I mean, I can easily
map it
if I wanted to, because I'm using it in a bunch of different places. I mean, really, it's the diagrams themselves that need to decide what color to render it in. So, maybe I should just bite the bullet and just remove this entirely. This whole color function crap that I'm doing, because that's what I'm doing.
But then you need to know what part of the encoding is what.
Well,
right.
Only for one of the diagrams do I need to know that. For the rest of them, I don't. It's only this one, the one at the top. That's not it. But you know, the one that shows the combined encoding, and you press the button and it shows the different colors or not. All the rest of them don't care. So the easy thing to do, I'm just going to do the easy thing right now, because I know what the on and this is I really don't like doing this. This is making me cringe. but I want to finish it. So okay. So I'm going to do it anyway. I'm going to cringe and I'm going to do it anyway. And I'm going to make a note that when I encode this, fix me. Don't process colors here. Encoding should be binary. All right, so I'll leave that for now. We'll go into Minicolumn competition, where we are deciding, excuse me. or we're processing the encoding. Render mini columns. Just following my logic here. And then where we get the encoding. So this right here really should be binary. I can change it inside of this. This is for the input though, which is fine. Actually, for the input, this works just fine. It is what I want for the input. It's just when I'm doing the overlaps, I can't do a binary. I have to change the encoding back to binary to do this comparison.
Yeah, I would just do the map in that one location for now.
Yeah, and I can't remember where exactly it was. It's this. It's right here. Yeah, it's right here before it. So what I'll do is I'll just do binary encoding equals encoding dot map color and basically I'll just return, well, I guess I'll just do it super easy. If color is what? On, off color, on combined color?
You want
This
me to-
one. No, I got it. We'll just say if it's on, if it's that, return 1. I think that was it. I'm not crazy with this, so I'm gonna fix this eventually. Hopefully don't still have that debugger in there. Oh my gosh. I keep pressing buttons and they're not doing what I want them to do. Okay, what do I got here? Still something. 111110. Okay, that's what I expected. Okay, so that's working now. So when I hit compete, I should see overlaps in here that are not all empty. Okay, they're not. They're not all empty. Okay, good. Okay, so now we can move on to whatever is actually happening that's not right, which is at this point in the mini column. This is now we're back in the real code base, the mini column competition code base. Okay. So here we have the encoding that we get here should be 1s and 0s. And we're gonna decide, since we're making them all gray, right? We were. So the fill, this is where I want to change. Oh shoot! What am I talking about? This isn't what this is fine. It's the mini column. It's the other part that I'm dealing with. This part. Yeah. Okay. This was this was where the overlaps were weird that I thought. Max overlap, min overlap. So now I want to make sure that those are populated properly. Because I need the max and min, good. Because the max and min overlap will help me create the color gradient. Because I want it from green to red, and if you don't have a min and a max, you can't create a gradient. I don't know exactly what they're going to be. So now I can call this green to red %. So if I come up with a % here using that, using those numbers, that's what I'm going to do. So for the fill, that's what I'm going to use instead of gray. We're sending in the overlaps. I know there's going to be a min in the map, so this D is the overlap, and it's going to be a number. And so our color is going to be basically red to, what did I call it? get green to red, and we give it a percent, not a decimal percent. I don't know why, but not a decimal percent. Okay, so I think I want like this plus, so I need to make a percent green to red. So we'll say const percent equals, and we're gonna be, so actually I'll do this with D3 scale linear. I totally overuse scale linear. So the domain is going to be from min overlap to max overlap, and the output range is 0 to 100. 0, yeah. I think that'll work. Or 0 to 99. I think 0 to 100 works. And I think that might work. Let's find out. But then I have to, this is my scale. Color scale, and I can now hoist this up here. Yeah. So now I can say, call color scale on the overlap value to get the percent green to red. Watch this fail. I hope it works though. Oh, debugger. Stupid debugger. Get out of here. I want to see it work. Work the first time. Come on. Oh, god dang it. So close. Right here. Shouldn't this... Okay. Overlap is 32. The scale. So let's see. What is this color scale going to return? Undefined. Min overlap. Okay, hold on a sec. Color scale dot domain is 10 to 32. That's the min and max overlap, right? Color scale dot range should be 0 to 100. The overlap is 32. So this should return. Maybe I have. Maybe my inclusive exclusive is off or something. Exclusive. That's kind of weird. So if I call color scale 10, that's 0. 11 should be a little higher. Should be a little higher. But then I go 30, 31, that should be almost 100%. 32 should be 100%. And our so why doesn't that work? Overlap. Oh, I have to say dot length, right? I have to say overlap dot overlap dot length, because that's actually what it is. Okay. I forgot. So the data that I'm calling to construct this, I could even simplify. Because I don't need all the overlaps. It's only on mouse over. I'll be showing the overlaps, but I'll be doing that in a different way, I think. So from this point, I could map this. Map O. Return O dot overlap dot length, just like I did before, and that should work. Just send it just the data that it needs. Yeah, wait a minute, that's not right. That's not right. That's not right. That's pretty like a sunset, but it's not right. It's because the overlaps are sorted, and I need to use the index. Like, okay, so I can't do what I was doing. I can't map them. I have to decide. That's right. Okay, I know what to do. I know what to do. I can't use the, I need to get, right here, I can't use this I anymore. I have to use d.index. I don't want this I anymore. I want d.index. Because it's coming from the data now, and it's not the arrangement of the data, and the data index is not I anymore. It's d.index. Okay. Oh, come on. So close, so close. We're very close here. Am I... Come on now. D.index is... That's right. Oh, so now it's just the color that's wrong. So the places are in the right place, but it's the color that's wrong. Perhaps. Color scale, overlap. Oh yeah, that's right, that's right. So now I still have to make up for the fact that this is overlap dot length. And that should fix it. So now everything should be in the right place and to be in the right color. Yes, all right. Here we go. This is the Minicolumn competition. You see how a lot of the same Minicolumns are active in the same places. Okay. We got a real visual. Thank you, Falco. Ah, it's amazing. It's creepy. What's going on? Okay. We've got a Minicolumn competition. Let's show the winners. Let's show the winners.
What does the colors mean again?
Overlap. So green is low overlap, red is high overlap. So the red ones are the most fully connected to the current input. And it's changing every time because the input's changing. Right over here. So as this changes, the overlaps change because all of the columns have different relationships to the input space. So some of them are randomly connected to different areas of the input space. So I'm not showing a selected column right now, but I'm only selecting one of these columns. Let's do that first. Let's make sure that the selected column is showing up, and then maybe a little bit more clear, because that's one thing that's a little tricky.
So the redder it is, the more overlap score.
Yes, and I might change that and make it green, make it the other way, but I haven't decided. I want to be consistent throughout what red and green means, but right now I'm just happy to get something visualizing. And you'll notice it's relative, so that's why I went with the min and the max overlap, so I can plot the colors between the min and max overlap. If I just picked 0 and 100, it would be different. Let's show you. I'll show you that too. If I just put 100 and 0 here, it'll be similar. I gotta put equals, I guess. It'll be similar, but it won't quite look, I think, as consistent. You can tell there is a little bit of a difference, but let's not do 100, let's do 50. You know, because you want the most expression you can between the red and the green, and so that's why I'm automatically, like, programmatically calculating the min and the max so that I can create that color scale range. So it looks a lot better when you know the min and the max, and you can take advantage of the entire range of colors on every time step. Okay, so I'm going to show the selected column first because that's confusing without showing the selected column. And the way I'm going to do that, I think, is stroke width. Maybe fill opacity. Okay, so let's try that. So everything was like 50% opacity. If it's selected, let's say if d.I equals selected Minicolumn, return 100% opacity, otherwise return 0.5. And hopefully we'll see like an indication as you move across it. No, maybe not. I don't know if I have the handle mouse move That isn't really working, is it? It could be my mouse move isn't working. Selected mini column and update. Update. If overlaps input space competition. I want to see if this is actually triggering or not, because I can't tell. It should be, like, at least once per... But it's not. Oh, violation mouse move handler. Something's wrong with my mouse move handler, it looks like. I probably have a bad mouse move. I didn't try and do that right at all. So I have attached on mouse move to the competition when I think it probably should be attached to mini columns. At least that's what I had it on the other one. That might make a difference. Maybe, maybe not. I don't know. No. It doesn't seem to. Handle mouse move. Let's start here. All right, we're triggering at least. So eTarget get attribute data index. That's probably we don't have the right data index. No, 417. 417 selected mini column, which is a valid mini column given that's totally a valid mini column. Update overlaps render input space render competition. This dot selected mini columns 417. So once we get down into here, we should fall right here, right? What are we not looking at? Oh, it's index. Stupid thing. Okay, index. Oh, wow. Okay. My fingers are starting to go nuts right now and like press all the wrong buttons. Okay, so this is index, this is index. Everything else I did index except for that one. Okay, let's one more time with feeling. There we go. Okay, so you can sort of see it. It's not very bright, honestly. Let's do this. Let's do that as well as this. Okay, so let's select. We're gonna change the fill opacity based on that, and we're gonna change the stroke. We're gonna make it red. We're gonna make it red for selected, and then black for if it's a winner mini column. So right now, we'll just return red here. Otherwise, I think I said what, dark gray. I hope that makes it more evident. Okay, so that's a little more evident that this is a selected mini column. So here's the thing to realize is that what you're seeing on the left here is this selected mini column's relationship to the input space, and its overlap score is higher, and this will become more evident as I plot the connections as well. That's the whole point of this visualization, so I'm glad you're asking questions about it. The whole overlap is higher when the input is on top of a bunch of connections that are permanences that are above the connection threshold, right? That's what we're trying to get at. Some of these are really low, and as we fill out this visualization, you'll see why they're low. It's because all of their connections happen to be in places where the bits aren't rolling across very often. So most of these high ones are ones that are mapped a lot over top of that scalar value moving up and down, I think. Okay, so we're getting somewhere. The other thing okay, so now I want to try and show the winners. So we're going to show the winners. So when we run compute, well, there's another thing I wanted to do. That's weird. All the dark gray borders around it are sort of overtaking this gray border. So we're going to also increase the stroke width. What was it before? 0.5. Okay. So basically I'm doing the same thing as the fill opacity. So we're going to increase the stroke width. That'll make it a bit more visible. Maybe even 1.5. And then we'll do, for winter columns, we'll have a higher stroke width too. It just makes, we'll twiddle with the visualizations too as we go along. For right now, I'm looking for functionality for the most part. So let's plot the winter columns now. And what the winter columns will be, basically the reddest of all of these will be the winners. At least that's what we should see when we're done. Okay, back to spatial pooling. Here's where we did the competition. And here's where we get our winner columns. So that's the winners. So again, I think this is something we need to set. So we have overlaps, and we're also going to have winners in this competition. This.state.winners. We'll just call it winners. Okay, so again, way up here. Undefined. And basically that's it. Winners, and we'll add that as a part of our state. Let's move that up one. Tricky, we could do this. As long as that actually executes first, this will work. We'll see. Okay, we're not doing anything with the winners yet, but we should be getting winners, and we should be able to use it now. We should be able to get to our state here and check to see if we're a winner, if one of these is a winner. So the winners, let's simplify it first, because it would be great if it were just a list of indices, and I don't think it is. Okay, I'm gonna take back what I did here, and we're going to say we're gonna map this to, I think it's just index, yeah, I think it's just index. So then we should get a map of indices. Let's make sure. Yep, map of indices. So these are the winner mini columns. Perfect. Okay, so that's what we want in here. And now, as we're deciding, I'm gonna get the winners. Make sure we can get the winners here. Constant winners equals this dot props dot winners. And we're gonna, what are we gonna change? We're gonna change our fill. No, we're gonna change our stroke, right? Yeah. So if it's selected, it's gonna be red. But also if d.index, and we'll say winners contains winners index of, right? Winners index of is not equal undefined, something like that. Can't believe there's no array it contains. We're gonna say black, and we're gonna do the same.
You say array contains?
Yeah, is there array contains?
It includes.
Includes. Okay. So if winners includes d.index. Perfect. And we're going to do the same thing here. If winners includes d.index or it's selected, we'll return a bigger start width. Cross your fingers. I bet this will work. Oh, it'll work. Yeah, so there's our winner columns, and they're the red columns. They're the highest overlap columns in the whole space. We are spatial pooling right now. This is spatial pooling. Very exciting.
So Matt,
yeah.
so this is spatial pooling with no K, I guess winner take all, no tie breaking, and no boost.
That's right. That's right.
Okay.
No tie breaking. Well, I'd say random tie breaking. And no boosting. Yeah. So, and we'll see it. So what I'd like to do with this visualization is create it like this. I don't even know if we're going to need to add tie breaking right away or not, but I want to show the deficiency when there's no boosting. So we'll try and move along with this, but then talk about active duty cycles. And then as soon as we plot the active duty cycles, it's really obvious that there's a ton of space in this system that is being underutilized. And then we'll add boosting. All right, this is exciting. Okay, let's see if we can get the connections done before I hang it up for the day. Because I bet we can. I'm gonna place that I'm gonna commit, I think. Let's see where we're at. Packet, okay, so we updated spatial pooler. We're working on Minicolumn competition. We're gonna do connections next. We've got the competition, the mini columns. Okay, the permanences, it's just a typo. Spatial pooling, a new diagram, new page state for overlaps and winners. Some crap I gotta fix. Right, adding the page state. That's what I gotta fix again. And then there it is. Okay, so that's pretty cut and dry. Okay. First pass at mini column competition diagram. No boosting, no tie breaking. Yeehaw, yeehaw. All right, I'm pushing this straight up. I'm pushing this to master. Might as well. Didn't create a PR. Sorry. Okay. Let's try and do some connections. So the idea being, let's look at this first. The idea being that when you select a mini column, you know, and I did this in the permanences. We're basically going to show the connections over the input space, just like we did on the permanences. But I want to show the connections that are hits and misses too. So there's going to be sort of two types of connections here. The ones that overlap with the input space, which will be filled in, and the ones that don't, which will just be circles. So we can do all of this, I think, with one pass in D3, just drawing circles over the input space. I don't think it'll take too long. I think we can do this in 20 minutes. Somebody time me, 20 minutes. I think I have a countdown. Don't I? Down 20 minutes. No, I took it off. All right, anyway, let's try this. Let's see if we can do this. All right, back into the mini column competition. We have rendered the input, rendered the potential pools, and now we're going to render connections. The connections is on top of the input space, they're going to be circles. Okay, so in order to do this, we've got our encoding. We already know it's just ones and zeros at this point. That should be okay. Potential pools, the selected mini column. I think this is gonna work. Let me just see what happens when, who knows, this might work. No, circle, property 0. So it's permanences, okay, 154. This dot props, permanences. I may not be passing permanences in. I am not. So I'm going to want to pass permanences in because I'm not doing the, when I do the overlaps, I don't have a function in the spatial pooler. There's water right there.
Yeah, I'm gonna get some.
Okay. I don't have a function in the spatial pooler that returns connections. It's super easy to do. Chat broke.
Chat broke?
Chat broke. I see your text on the screen. It's just super delayed, I think. I'm sorry, I like totally like lost my train of thought here. What was I saying?
Minecraft.
Oh, I was trying to decide whether I want to, yeah, so one thing I could do is just simply add permanences and then we'll just render the connections using a connection threshold. But then we also need to add a connection threshold, which we'll add too. So we're sending a lot of information into this diagram. It's going to respond to changes to any of these things, which is okay, you know, because we might want to, I mean, this just means that it's a super responsive diagram. If people change something, it's going to update. So now that we've got connection threshold and permanences, let's see, do we have this? Yeah, props. Now it might work. Connection color is not defined. All right, let's steal the connection color from the permanences diagram. Permanences connection color. Blue, of course. Selected color. Let's fix that. One of these days I'll fix all the colors, don't worry. What do we got? Oh, why is it over there? It shouldn't be over there. I think I have it in the wrong place. These connections should be over the input space. These are in the wrong place. So these connections are inside the input space. Am I render connections? It should be, oh, I'm transposing it explicitly. I think that was it. There we go. Okay, so those are all the connections. I want to selectively fill these circles only if there's input. So that should be easy. So the fill is none, so I'm going to say if D is over the connection threshold and the input, where's my input? Encoding. Let me do this. I want to get the encoding here. Encoding, and I can use that. And I can go, excuse me, see if the encoding, no, just encoding at I think, is 1, then we fill it. Otherwise, it's an open circle. Or not. Or not. Oh. Something else. I'm not drawing the stroke at all. So I always want to draw the stroke. Okay. There's 2 bits to this. There's the stroke and the fill. They're both treated. One of them is going to be based just on connection threshold. We'll always draw the stroke if the connection exists, like that. And we're gonna fill it only if the input is overlapping. So I've got something wrong here. So let me go look at my render input because that's where I was. So I'm not using the same data for this. I am using permanences, but I should still be able to, oh wait, yeah. That's right. See you, David. Thanks for sticking around and helping me out, man. Probably, oh no, I will not get to boosting and tie breaking today. Absolutely not. So next time. Well, maybe even not next time. I want to clean some stuff up. We've gotten pretty far on spatial pooling, so. But we'll definitely get there. We have to. So this,
Thanks, have a good one, guys.
Yeah, take care, David. So this is this source is the permanences, and the other source is the encoding. So I've got to sort of map from one to the other. If this is the encoding, I thought I should be able to say, oh, I'm looking in the wrong place. This is connections. Yeah. So I'm using the wrong index here. I need to find out D, I think I want D.index. D.index. Let's see if that works. No, okay, let's debug right here because I don't quite understand what I've got in my hands. Tie breaking is different than boosting. So tie breaking is simple. Let me show you real quick. Tie breaking is easy. Ugh. So remember in the HTML school where you've got a bunch of mini columns, and I drew them like this. I was like, here's the most connected mini columns with the most overlap, and then they come down like this, and we're like, okay, we only want the top 40. That's K, right? We only want the top 40. And so we just go 1, 2, 3, 4, 5, 6, 7, 8, 40, and we draw a line. And we're like, okay, we're only gonna take these. Well, what if this guy's overlap was 80, this guy's overlap was 80, this guy's overlap was 80, this guy's overlap was 80? Well, that's not fair. Why did we arbitrarily choose these? Don't we want to look through all of these and decide which ones are more relevant to win? So tie breaking is basically deciding when there's a tie condition like this, which mini columns are we going to choose to be the winner? And there's different ways you could do that. I don't remember how Nupic even does it. But boosting's totally different. Boosting is keeping track of all the active duty cycles and spreading activity to those that aren't very active. Okay, we're getting close here, so this shouldn't be too hard, I hope. So our encoding, what is D? D is, so maybe that's the problem. So the D, I'm just getting permanences, and the I, these are the permanences. This should be I should be the index of the input space where the circle is going to be. So I should be able to look into encoding and use I, encoding I. Oh, that's right. It's the colors. Your stinking colors. So this encoding, I thought I fixed that though. Didn't I do that in spatial pooling up here? Where we created, right here. We created a binary encoding. Oh, we only did that for the winners. I am gonna fix this. I swear I'm gonna fix this. But for right now, I'm not gonna fix this. I'm gonna, okay, I'm gonna make it really explicit that this is wrong and needs to be fixed, and I'll come back and fix it later. There shouldn't be 2 encodings in here. Yes, I'm cringing, but I want to get done. And so what's worked for me at this point is I'm gonna cringe while I'm doing the live stream. I'm gonna come back and clean up later, right? And the next time we do a stream, I will have cleaned up some things and I'll go over what's changed. And I think it'll be clearer that way in the long run. And I won't be cringing at that point. So I'm gonna pass the binary encoding along as part of this state, which is totally not what I want to do at all, but I'm gonna do it anyway because I just want to see this work. I want to see it work. So we're gonna call this binary encoding. So we're passing 2 redundant encodings into the system, and that's awful, but I'm gonna do it anyway. So now I should be able to say binary encoding. Yeah, and that's right. And this isn't D and X, this would just be I, and that should work. I hope. Show me the money. Show me the money. Yes, there we go. No, oh, it's wrong. It's wrong. It's totally wrong. Why is it wrong? That is interesting. Why is it wrong? I wonder if the, well, we're gonna have to debug. It's the fill that's the problem. So let's check right here. Okay. Encoding at I. So okay, I'm gonna add a couple watch statements, and we're gonna stop right there. I'll add watch. Die. Go away. Go away. We'll have encoding at I, so 1, and we'll have another watch, which is D, which is the permanence, and if D is D greater than the connection threshold. Okay, so those are all right. So the fill. Okay, so that's true. Encoding's on. Encoding's on. Encoding's on. We got to get to a point where there's some mismatch between the encoding I'm drawing in the previous. There's some mismatch. So when I'm drawing the input here, I'm passing in this .props.encoding, which is actually the colors, and that's what I'm using to fill it. Yeah, there's definitely some mismatch here. So the perms, when I'm doing this one, I'm doing it with the permanences. Okay. Okay. I think I've also got an indexing problem here. And I think right here, let's see, let's stop right here, because am I using the things that I think I'm using? Selected Minicolumn. So these are just raw permanences. There's nothing but scalar values in here. They are not objects. They do not have indices. That's the problem. I need to combine these with the pools. That's what I was doing. In order to find the proper index array, I need to have the pools. I already have the pools here, so I have to do the same thing. Okay, so it's not just the encoding index, it's the pools that has the index to the encoding, so I have to dive into that. If that will get me to the right place. All right, I think. I hope. I think that's right. I think that's it. That's it. So that's the problem. So now we can look and see why specific mini columns are active. And now at some point I want to have like something that controls the data flow, like at the top and the bottom. And you can see this is the data is moving everything on this page. This is great, by the way. I'm very happy with all of this. So the data is just going to keep flowing. I want to have like a pause button at some point and a step backward and forward at some point. But for right now, this is great. I'm getting the diagrams that I want, and we can start refining it and making them look nicer as we come along. Yeah, this looks very nice. Okay. And now, as I change these, it's going to completely reinitialize the spatial pooler, and it's going to change everything. Yeah, see, the potential pools change when I change these values because it has to be reinitialized. When I change this connection threshold, it shouldn't change, but it does. That's something I put a fix me about. But like, if I put the, we're still gonna, here's the thing. Look at this. This is weird, right? I've got the connection threshold so high that it's, oh, that's so strange. See, I don't even I don't even totally understand. See, the spatial pooler is not going to work if you just set it up with random stuff. Like, that's why you want to move the connection threshold, or at least move the distribution near it, like that. Whoops, no, 0.7, 0.7, there. Because now you've got better representation of the data. Oh yeah, that's cool. I bet it is a tiebreaker. You're right. You're right. Absolutely right. That's the issue. So if I put this like down here at 0.3, it's going to be so far away. This is basically, somebody just drew a line. So a better tiebreaker would be something more random than that. Anyway, let's push this and make sure that it deploys so other people can play around with it. All right, so I'm going to commit. I'm going to push. I'm going to deploy. We're going to watch it live so that you guys can play with it too. And then you guys can let me know who you want to raid, because I am just about done. Hello, ArcSam. Good to see you. Whew, yeah, we got a lot of work done today. I mean, check it out. This is I've been working on this for like I've been wanting to do this for a long time, and we are pretty damn close. I mean, pretty damn close. It's working, you know. So I'm stoked. I'm stoked. We still have more stuff to do. I want to add those thresholds that you can change and stuff like that. Some legends, but we're in a good place here for sure. Fire truck. Here it comes. Yeah, it must have been the fortune I ate. My fortune cookie. I didn't read the fortune. I just ate the whole thing. Watch out! Here they come. They're on the wrong side of the street and everything. Ah! Get out of the way. Okay. Scrolling right by. Okay. I am quick code review here. Okay, this is the Minicolumn diagram. Yeah, the colors. Got a lot of fix me's, I know. Fix me. Consolidate color handling. That's true. All right. Render connections is working. Competition, the Minicolumns, selective color, that's all good. And the spatial pooler, we are sending, this. Fix me. I don't want to do that, but I know I've got comments all over the place about that. All right. Added connections to Minicolumn competition diagram. All right, folks. Git push upstream master, git push Heroku master, and then we should see a deployment pop up soon at building dash HTM systems, not Heroku. This is a little bit behind, so it's not going to update right away. Oh, this is my last one though. No connections yet, but so anybody can see this if you want to check it out. It's live right there. And the latest version isn't up yet, but it should be within a few minutes. And that's the way it is. That's the way it goes. I want to see it deploy. There it goes. It's deploying. All right. Any raid suggestions, you guys? I got 7 viewers. Might as well give them to somebody. Have not been paying attention. I got raided by CM Griffing earlier. I'm seeing myself look at Twitch. Let's go to. Oh, let's do Serpent AI. He's doing like AI stuff. So if you want to learn about some AI stuff, that'd be a good place to go. So let's raid him. Before we do that, I want to see this work. Come on, show me the connections. Come on, show me the connections. It's still waiting. It's still build succeeded, compressing, blah 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 blah. All right, we're gonna set up to raid Serpent AI here. As soon as I see this deploy, we'll go do it. Come on, baby. Show me them connections. It's taking a long time, so it's almost there. There we go. There they are. There's our competition. Look at all that data. It's hardcore data visualization. All right, we are building a spatial pooler. We've got the Minicolumn competition down, sans tie breaking and boosting. And that's what we did today. And now I am not sure if there's going to be a research meeting tomorrow. I might have a stream tomorrow. I might not. Sorry, I don't really know. I'd like to have them a little bit more well prepared. Today I prepared for this, and I think it went better. So I'm gonna make sure that we prepare. So let's go raid Serpent AI, and tell him that we're doing AI stuff over here too, but not the same type of AI. So take care, everybody. Thanks for watching, and I will see you soon enough on the next stream. Of course, he's taking a break.